Once in a while, we get an article in the press about potentially dangerous asteroids. Now, usually it's actually about Apophis, which, as you might know already, is actually going to pass really close to planet Earth in 2029, but sometimes it's about some other asteroids passing really close to planet Earth. But in several videos you can find in the description, we've actually discussed the idea behind dangerous asteroids and how extremely unlikely any collision with any asteroid is to occur in the next few hundreds of years. And that's because NASA has a program known as KEOPS, the link for which you can find in the description, that actively searches for any dangerous asteroid, always keeping everything up to date, making sure that nothing dangerous is creeping up on us, which is of course part of the terrestrial defense network in order to protect planet Earth. But there is a bit of a caveat, and the caveat is that this is only in regards to asteroids and obviously comets, and the objects we can track very easy. There is, however, something else we can track, and for many years this unnerved a few scientists because of something that happened back in 1908. And well, hello wonderful person, this is Anton, and in this video we're going to be discussing the idea behind the Taurid swarm and the potential dangers coming from this swarm, especially because in 2032 planet Earth is going to be passing directly through it, which technically might cause a few collisions here and there. But here, without any speculations, let's actually discuss some of the science first and talk about what we know and what we don't know. Although first, so what is this swarm and what exactly formed it? Well, here's the simulation of the swarm created by the Western University, and you might already be able to tell what this unusual formation is. This is the result of an ancient comet, and we also know what comet this is most likely connected to. You can sort of see it right there. Comet Encke, also known as 2P Encke, is a typical periodic comet with an orbit of 3.3 years. And, like some other comets, it's also responsible for creating a meteor shower. And in this case, it's the Taurids, the shower that's actually peaking right now in October, and the shower that's also known to contain relatively large pieces compared to a lot of other meteor showers. But there is something else about it that's a little bit unusual. It's actually two separate showers, with a southern and a northern component, with both coming from two separate pieces. One is from Comet Encke, but the other one is from a potentially dangerous asteroid, 2004 TG10, and both of them have an extremely similar orbit. As a matter of fact, today it's believed that they very likely came from a much larger object that most likely broke apart a few thousand years ago. In case you're wondering, here's their orbit for comparison. And both of these objects are just over 1 kilometer in size. To be more exact, Encke is about 3 kilometers across, whereas 2004 TG10 is about 1.3 kilometers across. And because both objects are in a similar orbit and both contain signs of something falling apart, for several decades scientists believed that something much bigger very likely fell apart as a result of a close approach to the Sun. So some kind of a primordial comet, which is also usually referred to as Encke, but in this case much larger, potentially up to 100 kilometers in size. And when this larger piece fell apart, it created what's known as the Taurid complex, which is simulated right here. And so whatever this is, potentially contains lots of different pieces of all sorts of sizes, but exactly what pieces and how big they are has always been a mystery. Nevertheless, for many years now, this idea has been known as the Taurid complex giant comet hypothesis. Basically the idea that all of this came from a much larger comet that fell apart 10 to 11,000 years ago. But much more intriguingly, something else extremely unusual has been connected to this event. In 1908, the now famous Tunguska event that created an enormous explosion in Siberia, and that even today does not have a very good explanation, seems to have happened right in the middle of the passage through this unusual swarm. In other words, when this event occurred, Earth was actually passing through the Taurid swarm, and so many scientists believe that this rock, or whatever this was, potentially came from it. In other words, by passing through the swarm, the chance for a really large collision maybe, possibly, increases dramatically. Or at least it has increased in 1908. But because of the orbital dynamics, Earth does not pass through the swarm every year. It goes through the regions where we actually receive the Taurid showers, but not through the region with the thickest concentration of particles that represents this ancient cometary object. And so for several decades now, some scientists have been basically speculating that maybe just maybe, this Taurid swarm also potentially represents some kind of a danger to planet Earth. But in this case, a danger that's kind of difficult to predict. Mostly because we don't really know what's inside the swarm or even how big it is. And though in most cases meteors or those particles during meteor showers are just a little bit too small to be dangerous, the predictions here, based on the observations of several other objects, basically suggested that there could be large asteroids here, even asteroids capable of explosions much larger than Tunguska event. And in the past, scientists have even looked at the moon in order to see if there's any evidence for anything. Specifically, they looked at the increase in impacts on the moon, discovering that certain impacts did actually come from the Taurid swarm. Which of course once again suggested that there might be a slight increase in danger when it comes to passing through the swarm. And so by discovering the signs on the moon, and by discovering that Tunguska event was potentially connected to all of this as well, along with the fact that several other objects were also connected to Enki and 2004 TG20 asteroid, altogether this basically increased the chance for a potentially hazardous collision every time Earth passes through the swarm. But all of this was still a hypothesis, and so back in 2019, several researchers wanted to see if they can actually analyze the swarm as we pass really close to it, in order to discover if there is anything dangerous in it after all. Specifically focusing on larger pieces and larger rocks, and on trying to discover how much of it is there, and how likely are any of these pieces to collide with Earth. And so after these initial observations in 2019, astronomers finally had a bit of a relief. Compared to previous assumptions and previous calculations, here by looking at potential asteroids 100 meters in size or larger, they actually found way less than expected. And that's of course really important because any one of those asteroids, if they do hit planet Earth, they could cause quite a lot of damage. And because Taurid meteor shower is actually known to contain large pieces to begin with, this has always been a bit of a concern. But instead of finding a lot of larger rocks, initially in 2019, they just discovered a bunch of rocks that seemed to be much smaller in size. As a matter of fact, something that would be a typical meteorite. So nothing too dangerous. But these observations have not stopped. As a matter of fact, scientists have been conducting them pretty much every year now, refining their search and trying to discover something dangerous after all. And that's because of one important event. The event that's going to be happening in 2032. Turns out that in November of 2032, once again planet Earth is going to be going directly through the swarm. And if you remember, in 1908 when this happened, this potentially produced the Tunguska event. So basically the question here was really simple. Is something dangerous potentially going to happen in November of 2032, or are we more or less safe? And well now, just a few weeks ago, once again following detailed observations and very detailed calculations, specifically by using ZTF or Zwicky Transient Facility, the telescope that's able to survey very large expanses of night sky, discovering many objects all at once, scientists from the University of Maryland pretty much definitively confirmed that it's extremely unlikely that there's anything dangerous inside the Taurid swarm. Or to be more exact, they discovered that this particular swarm does not seem to harbor any dangerous asteroids, and instead of containing hundreds and even thousands of dangerous rocks, there actually only seems to be maybe 9 to maximum 14 pieces that are extremely unlikely to come close to planet Earth, and also seem to suggest that the size of the original comet was much smaller. Not 100 kilometers, but possibly closer to 10 kilometers, or even smaller. In other words, the comet Enki and all of the additional pieces most likely represent the majority of mass. And so right now this new study suggests that the risk of a collision or even a similar event to Tunguska is extremely low, simply based on the fact that very recent and very detailed observations did not uncover any dangerous pieces. And that's of course incredible news for planetary defense. It means that there's one less thing to worry about, and it also means that the Taurid swarm does not seem to be as dangerous as we previously believed. And obviously there are still some pieces that could potentially create a relatively large explosion. It's extremely unlikely that it's going to be happening in 2032, and it's extremely unlikely to be dangerous anytime soon. And in this case, all of this became possible because in the last few years, Earth passed relatively close to the swarm, allowing the researchers to scan all of these asteroids pretty much all at once. And inside of it, they just didn't find a lot of large pieces. But to confirm all of this is going to be done again and again in the next couple of years. And so basically, in 2025 and 2026, researchers are going to be doing these observations again, just to make sure that there's really nothing there. And naturally, on top of this, it's also helping us understand this idea of comets breaking apart, and helps us understand what happens to these objects when they come really close to the Sun and when they end up breaking apart over time. And because additional pieces like the current comet Enki are extremely likely to fall apart again, understanding how this happens and what ends up happening with these pieces afterwards is of course important. But at least for now, if you're watching this in 2032, unlike all of the press releases claiming something dangerous might happen, these studies suggest otherwise. It's extremely likely that nothing will happen, and the Taurid swarm does not seem to be dangerous after all. But chances are we're going to be coming back and talking more about this in the next few years again, mostly because there are going to be even more discoveries from a lot of additional studies, and I'm sure at some point we might even discover additional asteroids that are kind of exciting, hiding somewhere inside the swarm. Alright, let's discuss something really exciting, and something that many astronomers actually thought we'll never be able to find. A discovery of something around Saturn. And specifically, a discovery of the first ever Saturn's Trojan. An object that's technically an asteroid, but in a very specific orbit. And for a lot of astronomers studying the solar system, this is actually super exciting. Like, beyond exciting. Mostly because nobody actually thought these were even possible. And so, hello wonderful person, this is Anton. Let's discuss the discovery and the confirmation of this rock known as 2019 UO14 that was just confirmed a few hours ago, and talk about why for astronomers this is actually extremely exciting. And to begin, I think we have to define Trojans first. In essence, you kind of see them right there, visible in green. These are Trojans of Jupiter. And well, in essence, it's a small celestial body, usually the size of a typical asteroid, that shares an orbit with a planet, and actually remains stable in the same orbit as the planet for at least some time, usually thousands of years, sometimes millions of years. But there's a limit to where these orbits can form. You might already know about the Lagrange points, but in essence there are 5 points around every single planet where an object can actually have a relatively stable orbit. For example, telescopes like the James Webb and the Gaia telescope all currently orbit in the L2 point, where they can basically stay for years and years, only using a little bit of fuel to maintain a permanent stable orbit. Likewise, we have some satellites in L1, but it's actually L3, L4, and L5 that are particularly interesting. Mostly because objects in those orbits can stay there for a very long time, and can actually naturally assume those orbits, and have done so around many different planets. For example, planet Earth currently has at least 2 separate Trojans, 2010 TK7 that you see right here, and 2020 XL5. By definition, both of these are Trojans, or basically captured asteroids, that now share their orbit with planet Earth. And as you can see from this table right here, almost all planets have Trojans. Mars has them, Venus has them, Uranus and Neptune have a bunch too, actually possibly a lot more that we haven't discovered yet, simply because it's a little bit difficult to see those objects, and Jupiter has a lot. Like, a lot. Thousands identified and potentially millions still hiding. The NASA's Lucy mission is going to be exploring a lot of them in the next few years. But due to its small size, Mercury is believed to have none. Although what's really intriguing here is Saturn. It also seems to have none. And it was not clear why. Saturn, just like Jupiter, is actually a really massive object, and so many different studies try to actually explain what's happening here. Here's one of the more well-known studies that tries to explain why there are no Trojans around Saturn. In short though, it seems to be the result of the, bullying from Jupiter. Because Jupiter is about 3 times more massive than Saturn, it forces Saturn to assume a kind of a libration point, which basically creates a 5-2 resonance between Jupiter and Saturn, sometimes referred to as Laplace's great inequality. And so in other words, because of this gravitational interaction, researchers always believe that Saturn potentially cannot have Trojans. In other words, Jupiter destabilizes the entire region around Saturn, making it impossible for any of the asteroids to ever share the orbit with the ring planet. Technically all of them are actually ringed, but Saturn has the biggest rings. And so for basically decades, Because of Jupiter, it was actually believed that we're never going to find anything. Ironically, quite a few objects have been discovered around Mars, and in this case the explanation was that it's just a little bit closer to the asteroid belt and actually quite far from Jupiter, so the effects were not as dramatic. But what's unusual about the Martian Trojans is that they seem to be permanent. Their orbits are unlikely to change for a very long time. In contrast, Jupiter's Trojans do change every few thousand years. In this case, it's actually the Saturn and Saturn's gravitational influence that changes their orbits over time. And so since the discovery of the first Trojan around Jupiter back in 1906, for the past 100-something years the assumption was that there's just not going to be anything around Saturn. And so because of this 5-2 resonance between Jupiter and Saturn, any object that could become a Trojan of Saturn instead seems to become a Trojan of Jupiter. And here we're talking about objects like Centaurs that usually orbit between Jupiter and Neptune. And even though these Centaurs don't have permanent orbits, quite a lot of them end up becoming Trojans, assuming orbits around Jupiter, Uranus, or Neptune, with basically just Saturn being left behind. And that was the overall assumption ever since the first discovery, or the first Trojan, from back in 1906. But some researchers thought otherwise. They actually did think that there was a way for Saturn to potentially maintain an orbit for at least a few thousand years, with different types of research trying to prove this by essentially creating various models. And so some researchers truly believe that it's just a matter of time. And though over the years many researchers suggested there might be some Trojans out there, we just possibly misidentified them, unfortunately there was no proof, I guess until now. Yeah, looks like they were right. The study by Hui and his team officially confirmed that the object known as 2019 UO14 is indeed a Trojan of Saturn. The object that you can kind of see as this little dot in the image from the Hubble, or a slightly different dot in other telescopes. But here to confirm that this was a Trojan and not just a Centaur or some kind of a different asteroid, scientists had to look for data observing its motion for many years. And this actually involved several telescopes and observations from back in 2015. And luckily this was enough to establish that this object was indeed orbiting like a typical Trojan, located in the L4 Lagrange point. And even though previous calculations suggested that it should be basically impossible, we finally have direct evidence that it's not. But because this object was discovered in 2019, it obviously took a few years to finally prove all of this. And the biggest proof came from prior images from before 2019, when its position was officially confirmed. And so here now we know this object takes approximately 30 years to orbit once, and seems to orbit 60 degrees ahead of Saturn. But similar to other Trojans, especially the ones around Jupiter, its orbit is not permanent. This is a transitional rock, or a transient Trojan, that was most likely captured approximately 2,000 years ago, and was very likely a Centaur. And the scientists now believe that it's most likely going to become a Centaur or just an asteroid once again in approximately 1,000 years from now, which is not that different from a typical Trojan around Jupiter. Naturally, all of this instability is the result of gravitational influence from Jupiter. But on top of this, here, they were also able to measure its colors, which seem to be consistent with everything we see around Trojans of Jupiter, and even similar to Trojans of Neptune. But more importantly, extremely similar to Centaurs, which of course confirms its origins. But based on the observations, and specifically based on the temperature measurements, researchers behind the study actually think this could also be the first ever active Trojan, or basically a kind of a cometary object. But in this case, this is right now just an assumption. At the moment, there are no observations of any kind of activity from the surface. However, researchers believe that this object is maybe a little bit too hot, so it should be emitting something at some point. And so they actually suggest additional observations to potentially discover if this is actually a comet, or technically an active asteroid, like for example the famous object 29P, or several other objects that we've discussed in the video in the description. Either way though, this is a super exciting discovery because we finally have another object to add here, and in this case an object in orbit of Saturn, suggesting of course that this table now has to be updated. But at least for now, that's basically all we know about this object, 2019 UO14, even though this is probably one of the most exciting discoveries in terms of the solar system discoveries in 2024. So it's been quite a while since we've discussed Planet 9, or I guess the idea behind a hypothetical ninth planet somewhere on the outskirts of the solar system. But it's about time we've discussed it again, because just now a team of researchers released another study providing even more proof for its existence. Or, to be more exact, for the existence of something that seems to influence various bodies in the solar system, with the assumption being that it is maybe some kind of a planet. And so, hello wonderful person, this is Anton. Let's discuss Planet 9 once again, and I guess let's start with maybe a bit of a history in regards to videos about Planet 9. I was actually going through some of the oldest videos on the channel, and turns out that over 8.5 years ago, that's basically when the first video on Planet 9 was made. And back then there was a lot of excitement, mostly because a lot of evidence pointed at its existence. For example, the biggest piece of evidence was from very faraway objects beyond Neptune, and specifically objects we usually refer to as TNOs, trans-Neptunian objects. Basically, really large asteroids or dwarf planets, kind of similar to Pluto, with the best example being this right here. This is an image taken by Hubble Space Telescope. And this is Sedna, one of the more mysterious and one of the more distant objects out there, whose discovery actually kind of changed everything. And it was really the discovery of Sedna that even began the conversations about Planet 9. Its extreme distance from the Sun and its extremely high eccentricity, along with the fact that it's just too far away to be influenced by Neptune, here's basically what its orbit kind of looks like, kind of implied that something else must have influenced its orbit in order to create such high eccentricity. And so at a conference in 2012, a researcher by the name of Rodney Gomes proposed that there might be a planet somewhere out there responsible for this, but possibly responsible for a few more observations. For example, here is one. Notice how a lot of these unusual orbits seem to be sort of in a similar direction. This is referred to as clustering. And this unusual clustering is somewhat difficult to explain unless something really far away and something massive enough forces them to have these orbits. And so this clustering was the main evidence. Then there was the evidence of high inclination. A lot of these orbits are also not in the same plane of orbit as the rest of the solar system. They're very highly inclined, as if something pulled on them in order to make them orbit differently. There's actually a mechanism known as the Kozai mechanism that I think an older video explains better, but in essence this was the other piece of evidence, or at least some of the strongest evidence. There were actually a few more pieces, but this was enough to start looking, mostly because a planet here would explain pretty much everything. And although some of the scientists initially did not think this was possible and even tried to disprove this, even a couple of Caltech scientists who initially tried to disprove this eventually basically converted. They started to look for this planet because it kind of made sense. But the thing is, they all accepted the fact that unless we physically find it or physically see it, it's still just a conjecture and is not real. And so thus began an almost decade-long search for the mysterious Planet 9. For example, using the NASA's Wide Field Infrared Survey Explorer, able to detect even brown dwarfs really far away, as long as they emit a little bit of infrared light, and looking at other data from very big surveys such as Pan-STARRS. But even after a decade, so far, nothing. Nothing planet-sized, emitting any kind of radiation detected so far, which resulted in a lot of alternative propositions or potential explanations for why we observe what we observe. I think the one that went viral, we've discussed previously, is the one involving a black hole. Naturally, if you can see it, well, maybe it's a black hole. Possibly. And though detecting a primordial black hole in a solar system would certainly be very exciting, here it really felt more like some kind of a cop-out than a physical explanation for what we're seeing. Also, a black hole would probably produce a lot of other effects, and we're not observing this either. But additional observations using even larger surveys or even larger telescopes, such as for example the Dark Energy Survey known as DESI, we've discussed this previously in the video in the description, ended up discovering even more TNOs or trans-Neptunian objects whose orbits could now be also analyzed. And with over 800 now in database, some scientists realized that maybe previous clustering or previous observations were actually just some kind of a bias. In other words, observations from those few objects we've seen before seem to completely disappear once you add a few hundred more objects whose orbits are basically all over the place. And so a lot of scientists basically concluded that maybe the Planet 9 hypothesis was a little bit premature, with most of this even explainable with just orbit of Neptune and the evolution of the solar system over 4.5 billion years. But this obviously still did not explain Sedna and a few other objects and a few other observations. Moreover, we even had an unusual observation from another star system, the one we discussed previously and the one you see right here, where there was an exoplanet discovered in an extremely similar orbit to what we believe Planet 9 would have as well. Very eccentric, very far away from the star, and potentially very similar properties to Planet 9. And so this physically showed us that such planets are definitely possible. And so if possible around HD 106906, why not the solar system? But essentially by 2024, we were back to square one. Despite extended search, nothing was discovered, which is why certain researchers wanted to see if they can find more evidence or potentially find a better way to discover where it actually is. For example, currently it's believed to be maybe only about 5 masses of planet Earth, with the average distance of about 500 AU, or about 13 times as far away as Pluto is from the Sun. And so as a result, it would still be somewhat challenging to find it even with modern telescopes, with this new research actually claiming strongest statistical evidence so far. Once again focusing on the extreme trans-Neptunian objects, hundreds of which have been discovered by a lot of recent surveys such as DESI I mentioned previously. For example, there was an object discovered that was even more extreme than Sedna. It now has this somewhat difficult to pronounce name. And so this time, by analyzing the motion of previously overlooked TNOs, and specifically conducting simulations focusing on the evolution of their motion with and without hypothetical Planet 9, here they ended up with 2 very different results. And because the simulation here basically involved all possible gravitational influences, including the galactic tides from the Milky Way galaxy itself, the overall simulation was actually pretty accurate. But what exactly does this show us? Well, essentially it shows us that the simulated version with Planet 9 seems to resemble the solar system way more than the result without Planet 9. Or just to rephrase this, the overall architecture of the solar system seems to suggest some kind of an anomaly out there, a gravitational anomaly that creates orbital structure that we see. Without that anomaly, the solar system would look very different, with the anomaly potentially being Planet 9. Or maybe it's something else entirely. But Planet 9 just makes a little bit more sense. But that's obviously not the only explanation. Additional explanations previously even involved just the overall structure of the solar system itself. For example, maybe the Oort cloud contains a lot more mass and is structured very differently, and is actually the one responsible for producing all of this, with the anomaly in this case being that cloud surrounding the solar system. That's essentially the cloud producing most of the comets. Or maybe it is a primordial black hole. Basically, the idea here is that something is gravitationally influencing things, but we just don't really know what. Luckily for us though, if it's a planet, we should be able to discover this with a lot of new telescopes that are going to be doing additional surveys in the next few years. And so if after 1 decade we find nothing, then all of this will have to be reassessed once again. The evidence though is pretty strong. It's just nobody really knows what's causing this. Hello wonderful person, this is Anton, and today we're going to discuss some of the most recent discoveries about one of the strangest objects in the solar system, or at least the strangest cometary object. An object that, despite technically being a comet, never produces any tails, usually has very unpredictable eruptions, and to be more exact, is actually a giant space volcano. An object we refer to as 29P Schwarzmann-Wachmann, I think. Okay, let me try this again. Schwarzmann-Wachmann. Anyway, the name is right here. And while ever since its original discovery, this object was always a little bit more mysterious compared to every other comet. Because first of all, it's actually something that's known as a Centaur, a type of a larger asteroid or a larger comet, usually orbiting between Jupiter and Neptune, that we actually believe most likely came from the Kuiper's belt. And though quite a lot of Centaurs are known to us, only approximately 30 have actually been discovered to contain cometary features. Interestingly, one of them made the news in the early 2024 when a different object known as 12P Pons-Brooks, a comet on an elliptical orbit of 71 years, whose original emissions looked something like this, was actually discovered to contain unusual horns, or unusual spirals, that only became visible when the images were processed. And this unusual comet, that sometimes is also referred to as the Devil Comet because of these horns, was captured by several amateur astronomers, including Juris Senikovs, who captured this from Latvia. You can find the original pictures in the description below. In essence, once again confirming that these unusual comets are very different from a lot of similar objects. Here, these unusual spirals can only be produced as a result of massive volcanic eruptions, or basically emissions of cryomagma, which happens when the solar radiation cracks the object open, with a lot of cryomagma spewing out as a result of internal pressure. And so for approximately 30 of these objects, we actually see these emissions quite regularly during the closest approach to the Sun. So for this object, it usually happens every 7 years. But for 29P, the story seems to be a little bit different. This is the only Centaur known to us, and the only cryovolcano known to us, that seems to have extremely unpredictable emissions that happen quite a lot, and in some cases make this object ridiculously bright. This time, just a few days ago from when I'm making this video, it went up in brightness by a ridiculous 300 times. Essentially in what seems to be just sheer hours. Once again reminding us that this is really one of the most mysterious objects out there, and to this day, scientists have actually had a lot of trouble trying to explain this, although one of the recent observations from the James Webb potentially provided some clues. We'll talk about this in just a moment. But first, so what do we actually know about this as a fact? Well, we do know that this is a relatively large object, possibly 60 kilometers or 37 miles across. We also know that with every single eruption, it always produces these unusual reflective clouds, which seem to be the result of cryomagma flying into outer space. And that's actually what makes it so bright. The reflection from this cryomagma, as it spreads away from the comet, makes it appear ridiculously bright as the sun reflects from all of these particles. And in some of the previous studies, researchers basically estimated that eruptions here seem to happen at least 7.3 times per year. Or at least that's the average number. The actual eruptions are still extremely difficult to predict. As a matter of fact, last year, in 2023, we've discussed the first time ever such prediction was technically made. You can learn about this in a video in the description, but in a nutshell, scientists finally saw some initial signs predicting an upcoming eruption. And the only explanation we have for these unusual 7.3 times per year eruptions is just the fact that maybe this is actually how fast it's spinning. So basically here, if it had a 57-day periodicity, suggesting that it spins really slowly, this could explain some of these eruptions. But because they're not exactly 7.3 times per year, it's still unclear exactly what's happening here. And one of the biggest mysteries is really the fact that, well, it's technically in a very circular orbit. You can see the orbit right here. And so it never really gets too close to the Sun, unlike other comets, which means that it technically shouldn't even have eruptions, and obviously should never become a comet. And well, it doesn't. It does not get a tail, it never really gets close to the Sun, and does not acquire typical cometary features. Yet it does erupt, which is why most scientists refer to this as a true cryovolcano. Basically, a space volcano that for some reason erupts once in a while. And its last major eruption that increased its brightness dramatically was approximately 3 years back. We've also discussed that one as well in one of the videos in the description, and back then this was just as mysterious as today. We basically have no explanation for why sometimes it erupts so dramatically, and why it has these unusual explosive outbursts. And so these recent eruptions that started on November 2nd basically resulted in some of the most explosive events lasting for approximately 48 hours. And this time everyone failed to predict this in advance, and nobody expected this to be so bright and so explosive, which at first suggested that, once again, we don't really know what's happening. But then we had this additional study from just a few months back that did actually observe this comet with the James Webb Space Telescope. And here this was one of the observations of the outgassing events that discovered something we did not really expect at all. Here, as you can see from this image, there were actually two separate emissions of two different gases. On the one side we had the carbon monoxide jet with a little bit of carbon dioxide, but on the other side we only had carbon dioxide. This beautiful illustration shows us what most likely happened here and what this comet potentially resembles. And notice how this kind of looks like something we might have seen before, something from a different NASA mission. Here it potentially resembles the famous Arrokoth, the object captured by the New Horizons mission that to this date is basically the farthest object we've ever been able to capture on camera. And so here, because there were two separate emissions, researchers actually now think that it's most likely some kind of an aggregate object, basically containing at least two large pieces, and very likely resembling a lot of other similar objects detected on the outskirts. Here, just like Arakoth, it might be composed of two planetesimals, approximately 20 kilometers each, and each of the pieces contains different composition and very likely different structure, with one piece containing a lot of carbon monoxide, but the other piece containing a lot more carbon dioxide. And that's basically because we had two unusual jets. Two jets of carbon dioxide in the north and the south direction, and another jet with only carbon monoxide pointing in the north. It would be difficult to explain this if this was a single object containing the same materials. And so the most likely explanation right now is that this is basically two ancient pieces coalescing into a single object, which were very likely formed on the outskirts in the Kuiper's belt. But eventually, just like so many other Centaurs, it made its way into the inner solar system and is now stuck orbiting every 15 years in a somewhat circular orbit around the Sun. But because it's made out of this pristine material, sometimes, for some unknown reasons, very likely because of its very slow rotation, it seems to overheat and become extremely pressurized and produces these incredible cryovolcanoes 7 times per year. Or at least that's the current explanation based on the observations from the James Webb. Now this obviously doesn't explain why the emissions seem to be different and why sometimes they're so explosive, but it definitely explains the difference in composition. And since these pieces represent leftovers from the early solar system, honestly, this would be one of the most exciting objects we could visit one day in order to basically learn about planetary formation and the early solar system. As a matter of fact, we don't have to visit a lot of those other Kuiper belt objects, we just have to visit this one to discover what's going on. But unfortunately right now, no mission to this object has been planned by anyone, with the only mission that's even going to these regions, the Lucy mission, unfortunately currently having no plans to visit any of these Centaurs. It's going to be visiting the Trojans of Jupiter, so essentially these are kind of similar, but hopefully after it visits everything, maybe we'll have just enough fuel to possibly stop by this object as well. Or at least I hope so. I'm gonna cross my fingers here. Either way, based on these initial observations, if these assumptions are correct, this could definitively rewrite our assumptions about how we think a lot of these primordial objects are formed and how they're transported from the Kuiper's belt to the inner solar system, while also hinting that many of these objects potentially delivered a lot of stuff to the inner solar system, including maybe planet Earth. So yeah, a super important object, but an object we know very little about, which means that we'll come back and talk more about this once there are some additional observations, or once someone else discovers something absolutely incredible about 29P, especially after this recent extreme eruption. So the thing about our solar system is that it has some really unusual phenomena in it that are difficult to explain. And here we're talking about phenomena involving orbits of certain objects. For example, certain objects, such as Sedna that you see right here, have such an unusual eccentric orbit that it's almost impossible to explain by using solar system formation models such as the famous NICE model. And while Sedna is just one of many different trans-Neptunian objects discovered in the last decade that seem to have these orbits that are just impossible to explain unless something else is out there in the solar system or something happened to the solar system a long time ago. And well, as you might have heard before, one of the major explanations that tried to tackle all of this involved a hypothetical Planet 9. A planet potentially orbiting somewhere on the outskirts of the solar system that might have influenced the orbits of these objects, eventually causing these orbits to become super eccentric. But after a decade of extremely thorough search, so far no signs of any planet has been discovered anywhere, which as a result led to some additional explanations or potentially alternative propositions. Maybe there is no Planet 9, and maybe even that NICE model is not totally complete. But how can these unusual orbits be explained without some kind of an object out there influencing them? Well, we do actually have a really intriguing paper now by Suzanne Pfalzner and her team that tries to explain this with essentially a stellar flyby. Or in essence, a visitation by another star, a really massive star, that possibly shifted everything in the solar system and caused certain objects to orbit in a certain way. And though this might sound like a kind of a really simple explanation, and maybe even just a little bit too far-fetched, here the evidence right now is actually really substantial. And so let's discuss this in more detail, but first by starting with facts and observational evidence from somewhere else. Okay, first of all, as of 2024, over 3,000 small objects have been discovered to orbit beyond Neptune. And surprisingly, a lot of these trans-Neptunian objects seem to have both eccentric and highly inclined orbits. Or basically they orbit in a very different way from most of the planets in the solar system. And in the original NEAS model, this was all explained by having planets interact with various trans-Neptunian objects that actually formed much closer to the Sun, eventually scattering all of them outwards because of powerful gravitational interactions. And so in this model, the initial solar system was very compact and involved a somewhat thick disk. But here things don't actually make sense, because the resulting orbits would not match this. And there are so many of these TNOs discovered in just the last few years that seem to have these unusual orbits. As a matter of fact, in one of the most recent papers from just like 2 months ago, scientists using the Subaru telescope were able to discover 70 more TNOs in extremely faraway regions of the solar system, and all of them seem to possess unusual orbits. And though obviously before this was proposed to be signs of the Planet 9, today more and more evidence suggests that it's maybe something else. Now, this doesn't invalidate Planet 9 hypothesis just yet, but all these new discoveries do make it just a little bit less likely. And so the existence of various trans-Neptunian objects with high inclinations and peculiar orbits is extremely unlikely to be the product of just simple scattering by planets. Then, at the same time, we also have a lot of different observations of various early planetary systems, and of course various protoplanetary disks, with many actually showing signs of some kind of a star interaction, or essentially a stellar flyby. And here, even in somewhat low-density clusters, at least 1% of these objects experienced a flyby. But in most cases, such as for example in NGC 2244 or the Rosetta Nebula, this percentage seems to be anywhere from 8 to 15% for a typical star like our Sun. So essentially, out of all stars here, 15% seem to experience some kind of a flyby in the first 10 million years. And that's obviously because they actually form in really dense molecular clouds that contain a lot of stars nearby, where these encounters become very frequent. And so overall, these flybys are actually not as infrequent as researchers initially believed. But they do become less frequent as the star gets older, and of course, as it escapes the molecular cloud and as it goes on its own merry way. And so according to this study, based on all of these observations, for a star like our Sun, after 4.5 billion years, the likelihood for a flyby is somewhere between 20 to 30% in total. And here we're not just talking about a flyby at a distance of several light years, we're actually talking about a star entering the solar system and passing within 100 astronomical units away from the center. And though it's only 20 to 30% likelihood, based on the observations from the solar system, it looks like it might have happened here after all. And so here the researchers actually wanted to find out, so what would happen if star did fly by, and how would the solar system develop then? And to answer this question, they essentially ran various computer simulations involving 12,000 years of star formation and several different passages from different angles at different speeds and at different distances. And interestingly, here they were able to recreate certain parameters of the early solar system, including Sedna-like objects and various TNOs on highly inclined orbits. But these simulations produced something else. They produced retrograde objects, or basically TNOs or various objects moving in the opposite direction. And to the scientists behind this paper, at first implied that maybe their simulation was incorrect. But then they came upon studies where other researchers have actually found these retrograde TNOs, such as the object sometimes referred to as Niku. And intriguingly, this is not something that could be explained by objects like Planet 9, but is something that's explained in their simulation involving a flyby. And specifically, a flyby of a star approximately 80% the solar mass, passing within 110 astronomical units at an angle of 70 degrees. And here the results produced extremely similar orbits, including Sedna and all of the unusual TNOs, as well as you can see from this simulation, a lot of additional objects that still have not been discovered, but have now been technically predicted by this study, which suggests that there are so many more of these objects out there, which, if discovered, would confirm this hypothesis almost right away. But all of this would have to happen very early on, possibly within about 10 million years of the formation of the Sun. Intriguingly, if this is actually the case, maybe this could also explain why one of these objects eventually collided with the early Earth, leading to the formation of the Moon, with additional collisions happening around Venus, Mercury, Mars, and pretty much all of the other planets, including Uranus, that possibly received the largest collision so far. So basically maybe here, all of these collisions were the result of this initial passage that disturbed a lot of objects and caused a lot of collisions over time. And on top of this, in a separate study, the scientists also proposed that quite a lot of retrograde moons of various planets may also be some of these TNOs that eventually got captured by planets over time. Quite a few of these exist around Jupiter and Saturn, and they do possess somewhat peculiar orbits. And since the observations from the Japanese Subaru telescope and even the observations from the New Horizons mission seem to provide more evidence for the existence of these unusual objects, even at faraway distances, at the moment this may not seem so far-fetched after all. And it's probably the Vera Rubin Observatory that's going to provide more evidence for all of this if it suddenly starts discovering more and more of these TNOs in certain locations, yet still does not discover Planet 9. But I guess one question that we cannot answer right now is, how likely did this also cause the collision of Theia and planet Earth? And did this flyby actually increase the chances for life to develop on planet Earth? In other words, do these flybys change the star system so much that it basically increases the chance for life to develop on one of the planets? Now, this is not something we're going to be answering anytime soon, but it is an intriguing question to ponder, especially once we get even more evidence with future telescopes. And in this video, I wanted to discuss a relatively new, intriguing study in regards to a concept known as the Lagrange points, and in regards to the idea behind the size of the solar system. Or basically, how far does the solar system actually extend? Because in this recent study, the two researchers, Edward Bill Bruno and James Green, propose an intriguing gravitational point relatively far from the Sun that can potentially capture a lot of extrasolar objects. Things like, for example, asteroids, possibly things like comets, similar to Oumuamua, or maybe even rogue planets, and something beyond that. And so let's talk about this in a little bit more detail, but I guess let's start with the idea behind Lagrange points first. Sometimes also referred to as Lagrangian points or libration points. And in essence, these are unusual gravitational stability points that can form between two massive bodies. Here's an example of these points formed between the Sun and planet Earth. And so here we have 5 points where in theory you could actually place some kind of a satellite or some kind of an object, and it would possibly orbit in these regions without falling on planet Earth or without falling into the Sun. And that's exactly what we as humans have been doing by launching and placing satellites there, and by then using them for various scientific purposes. Now, there are no satellites in the L3 point, but there are some in L4 and L5, mostly watching the Sun. There are some in L1 doing the same, but more recently it's actually the L2 point that became extremely popular and very important for science. This is of course the place where the James Webb is located, but also the Gaia telescope and more recently Euclid. This point is approximately 1.5 million kilometers away from planet Earth, and by placing a satellite here, it no longer has to deal with the Earth's magnetosphere, which can actually produce a lot of disturbances and a lot of interference with various devices, and you also get a direct line of sight to planet Earth, which means that data transfers become very easy. But the thing is, these are not permanent spots, and so at least a little bit of fuel needs to be expended in order to maintain the orbit for at least a few decades, which is exactly why the James Webb Space Telescope mission is really only going to last approximately 20 years. It's at some point going to run out of fuel. And so in that sense, L1, L2 and L3 points are technically in unstable equilibrium. Things in these orbits will eventually fall out of these orbits, and so we're unlikely to find some kind of a prominent asteroid or even some kind of a prominent minor planet orbiting in these locations. But it's the opposite for L4 and L5. These are stable points, and so in these positions we do find certain natural satellites, quite a lot of asteroids, and for planets like Jupiter, quite a lot of minor planets, at least a few thousand, but more likely millions or even more. And sometimes we refer to these as Trojans, and Greeks, depending on the position. And today we know that quite a lot of planets seem to have these, even smaller planets like Mars. But I guess the question is, why am I talking about the solar system if in the beginning I mentioned that we're going to be talking about much farther distances? Well, here it's important to understand that two massive bodies, when one is more massive than the other, tend to produce these Lagrange points that sometimes can capture objects for a very long time. And so it turns out that this can also apply to outside of the solar system, or at least the location that we thought was outside, but could technically be still considered to be part of the solar system if the study that you can find in the description is actually correct. And so in this recent study, Belbruno and Green do a bit of math magic to actually discover that there is something else going on between the solar system, or I guess technically the Sun, and the center of the galaxy, and specifically the galactic center that contains the largest concentration of mass in the Milky Way galaxy. And so here, by modeling the Sun and a lot of the surrounding space, they were able to identify points of gravitational balance, or points that I guess are known as Lagrange points for the solar system, but in this case between the Sun and the Milky Way center. And interestingly, it seems to be at approximately 3.81 light years away from the Sun, pointing toward the galactic center. And for this region, there might be at least 2 points where various objects can enter the unusual orbit around the Sun, to some extent placing them in a very strange elliptical orbit around an imaginary point. And strangely enough, their analysis shows that a lot of these objects could actually remain in these orbits pretty much forever. Unless, of course, something else passed by relatively close to them, disturbing them in the process. And so here naturally one example could be stars like Alpha Centauri that's located approximately 4.2 light years away from us. But bizarrely enough, the calculations here show that, in theory, it might become possible to not just capture asteroids and comets, it might also be possible to capture rogue planets. In other words, there might be a bunch of rogue planets orbiting in this region, and in theory they could have stayed here for billions of years. And in the process they would also obviously disturb a lot of other objects, such as various comets, or various asteroids, which would then, over time, move closer to the inner solar system, passing through it, or maybe even colliding with something else. Now, in some sense, it might explain the existence of Oumuamua and the comet Borisov, discovered a few years back, although because they didn't really come from this particular location, it might be kind of difficult to prove. But I guess more importantly, it technically means that if there are some planets or some objects orbiting here, and if to some extent this is basically a type of a Lagrange point, it would mean that the size of the solar system is actually much larger, at least 3.81 light years in terms of radius. Because in some sense, here we're talking about a capture of various objects by the solar system itself. And since here we're talking about a relatively prominent capture, it would definitely expand the solar system by at least 4 times. But just to clarify, here we're only talking about a relatively small opening somewhere inside the heliosphere produced by the Sun that seems to exist toward the galactic center and also away from it. And so here we're talking about the equivalent of L1 and L2 points. And the other somewhat strange discovery here is basically the orbits produced by these objects. If they're real, they would produce unusual fractal patterns that would resemble unusual shapes if seen from planet Earth, moving around in strange elliptical shapes, but basically taking billions of years to possibly complete. And naturally, if any of this is real, in theory we should be able to see these objects with the upcoming Vera Rubin Observatory. It's going to become operational in 2025, and so maybe in the next few years, something here might be discovered after all. But in reality, discovering a rogue planet here is extremely unlikely, and the reasoning behind this is really simple. If these points are real, and if capturing a permanent object here is relatively common, we would most likely expect at least one brown dwarf and at least one star to be captured here as well. And we know that there are no stars here, and no brown dwarfs at these close distances have ever been discovered, which means that this is still a hypothesis. But this gravitational point is most likely real, it's just we don't really know if the orbits here are permanent. For all we know, maybe a lot of stars actually compete with each other, shifting this point all over the place, and so in that sense maybe this is not a Lagrange point and instead represents an entirely different phenomenon. Nevertheless, still a really cool study and a really cool discovery, and if confirmed, is going to redefine the total size of the solar system. And today we're going to discuss a somewhat intriguing new concept from right here in the solar system that's now referred to as a dark comet. Something that actually started with the mystery that you see right here, the famous Oumuamua. But something that now, a few years later, has become a new scientific field and seems to be actually an intriguing new type of an object we never knew existed. And so let's talk about some of the recent studies about this and discuss what all of this means and why it's actually kind of important for the protection of planet Earth. But here just a brief reminder. So back in 2017, completely by accident, researchers discovered the first ever interstellar object, Oumuamua. And though technically we're not even sure what it really looks like, because at first it was believed to be some kind of a cigar-like object, but later on it was assumed to be some kind of a pancake, what we're absolutely certain about is that during its transition in the solar system, for some reason it actually started to display very tiny signs of acceleration, which is of course why it became an overnight sensation, because certain scientists started to claim that, yeah, this is a sign of some kind of an extraterrestrial intelligence and potentially signs of some kind of an ancient probe from a species far, far away. But you might want to check out some of the previous videos in the description to find out why, I'm sorry, but that's really bollocks. It's really not. It's not aliens, it is just a rock. But a very special rock, as we've discovered pretty quickly. Because several additional observations and investigations did actually discover that it was doing something very bizarre. It was basically exhibiting cometary features without the actual cometary tail. Or in other words, it was behaving like a typical comet, accelerating and decelerating as a result of some kind of an emission, but no matter how hard we tried, nobody could find these emissions. Or at least nobody could find them at first. Once again, some of the videos in the description talk about this a little bit more. And so this very bizarre change in trajectory began something really exciting. It gave some scientists an idea to possibly look for something very similar right here in the solar system. In other words, do we actually have similar objects that potentially display similar acceleration without any emissions? In this case, a lot of scientific studies essentially revealed that this type of an acceleration would indeed be possible if certain volatile gases were being released by this object, because this type of an outgassing can definitely explain everything we're observing. But here the new question was, what exactly was escaping and what's outgassing, since we can't seem to see it? And intriguingly, there was an earlier study from practically a year before that, from March of 2016, that actually did discover something bizarrely similar. Not similar in the sense that it came from the interstellar space, but in the sense that it was also exhibiting acceleration without visible outgassing. This was originally discussed in this study, but basically as a kind of a hypothetical proposition. And in this case, they actually discovered 42 separate asteroids whose acceleration was believed to be at least 3 times stronger than what should be possible from the effect known as Yarkovsky effect, which is a pretty well-known phenomenon that happens on every single asteroid as a result of solar radiation. Basically, as the asteroid spins, it heats up on one side, with that heated side then basically acting like a tiny rocket engine, which in every single case gives asteroids a very, very tiny propulsion. And in some cases, it also makes them spin a little bit faster. But this is a very minute effect and seems to be incomparable to cometary effects. And so that study from 2016 discovered a bunch of asteroids that were essentially doing something entirely different. With one asteroid in particular, 2003 RM, basically becoming a target of many different studies. And intriguingly, the actual effects from this asteroid were extremely similar to what were observed during the passage of Oumuamua. The overall acceleration and deceleration was surprisingly identical, and once again unexplainable by any known effect. And so the question here was, okay, so what's happening? Is this actually an asteroid, or is this a comet? And if so, what kind of a comet can this be? And that's because technically comets and asteroids are distinct objects. For example, a typical asteroid, supposed to contain a lot of rocky materials and can withstand solar radiation much longer, thus being able to survive much closer to the Sun, even in the inner regions very close to Venus and obviously planet Earth. Whereas for a typical comet, we expect them to come from the outer solar system, but also contain a lot of icy molecules, frozen for billions of years, and then suddenly evaporated once these comets come close to the Sun as a result of some kind of a gravitational disturbance, most likely by giant planets like Jupiter, Saturn, Neptune and Uranus, or maybe by something else entirely from billions of years ago. For example, technically, a passage of a star close to the solar system tens of millions of years ago would disturb enough comets on the outskirts, sending them toward the inner solar system, making some of them come close to the Sun millions of years later. And as soon as they come close to the Sun, they produce their iconic tail, and sometimes fall apart when they get really close to the Sun as a result of internal rupture. But in the last few decades, researchers also discovered something in between, or some objects that seem to meet none of these criteria. We actually discussed one of the more unusual objects in one of the recent videos. That was the discussion about the so-called space volcano. But today we're going to discuss this new category that seems to exist as well. And well, it's now referred to as dark comets. Basically, a kind of a new space rock that seems to also exhibit cometary features without the visible tail. Or essentially a kind of a hybrid, a comet asteroid. And it looks like Oumuamua was definitely one of these objects. And while in the last few months there have been some major updates about these objects, mostly coming from two papers we're going to be discussing today. The paper by Seligman and his team on two distinct populations of dark comets, and Astor Taylor and his team on the potential origins of these comets and basically how they possibly evolve. And the thing is, these studies are now super important. And that's actually for one really important reason. It's now been suggested that many of these objects seem to actually pose a much larger threat to planet Earth than we ever thought possible. Mostly because, unlike other asteroids that only rely on the Yarkovsky effect, since these objects become comets and can actually accelerate unpredictably, these small, rapidly spinning objects can and very likely do come close to planet Earth, possibly even colliding with the planet once in a while, with a lot of recent studies even suggesting that these comets potentially served as a delivery system for a lot of different elements, including actually water. And that's the intriguing part. It's now been suggested that one of the things that evaporates from the surface, and that's of course difficult to see, is maybe water particles. In other words, one of the outgassing materials that seems to be able to cause non-gravitational acceleration is maybe water molecules. But as of today, no signs of water have been seen from these objects, and so even now this is just a hypothesis. Nevertheless, dark comets are now a really strong candidate for how water was maybe delivered to planet Earth early on. And according to these two recent studies, first of all, they seem to fall into two distinct populations. Larger ones, mostly residing in the outer solar system close to Jupiter, and smaller ones in the inner solar system, usually in the asteroid belt. And so here, by studying the reflectivity of these objects and by studying their orbits, researchers behind this recent study were able to categorize them into two separate kinds. The outer dark comets, which seem to be kind of similar to Jupiter family comets, seem to have very eccentric orbits and seem to be relatively large, at least a few hundred meters across and sometimes even a few kilometers. These are obviously much more dangerous, but they also seem to be much more far away, unlikely to come close to planet Earth anytime soon. Whereas the second group is much closer, mostly located in the inner solar system, but luckily for us, usually have nearly circular orbits and are only tens of meters across. An asteroid of this size would definitely cause some damage, but would not be tremendously destructive. Here, the airburst would be kind of similar to what happened during the Chelyabinsk event in 2013. And these smaller, closer dark comets seem to mostly come from the asteroid belt, with their orbit potentially disrupted by Jupiter or Saturn. And it is quite possible that the larger dark comets created the smaller dark comets, or basically the collision of dark comets on the outskirts of the solar system possibly created a bunch of fragments that then traveled to the asteroid belt. Or maybe they're not related at all. I mean, right now we barely know anything about them, so everything is essentially a hypothesis. But we are finding more and more of these objects, and in just the last year, 7 more have officially been confirmed. But that's still not a large number. In total, we actually know of just 15 such objects, or at least the ones that have been confirmed through various studies. And I guess what's intriguing about all of these objects so far is that, compared to even other asteroids, they seem to be really strong. A lot of them do spin really fast, which suggests that they do have enough internal strength to not fall apart, which does suggest a slightly different composition from other asteroids, and naturally the composition and of course the origin that we cannot explain yet. But once we can figure out their origin, things will make a lot more sense. For example, right now this is the only explanation we have. Maybe they all started as Jupiter family comets, that eventually shrunk in size, reaching the point where only invisible volatiles were now being produced. And in this case, researchers believe that it could be all the result of how fast the initial object is spinning. And so if it spins really fast and starts spinning more and more, this might cause a disintegration and the loss of volatiles, which eventually produces smaller, less active objects, some of them becoming these dark comets. And so based on the study and based on some of the previous observations, researchers here provide at least several examples, essentially showing us this evolutionary process. But here this doesn't answer a lot of important questions. For example, what's evaporating? What causes this anomalous acceleration? And what causes invisible outgassing? Since so far nothing specific has been observed, we're not going to know much more about their evolution or their origin, because we just don't know what's inside of them. Which of course means maybe two things. One is that we have to try to find a way to study this with telescopes like the James Webb in order to actually observe what molecules are produced here, although in this case this would be challenging since these are really small objects and also seem to move pretty fast across the night skies. And so basically here tracking an asteroid in the asteroid belt might actually be a little bit challenging for the James Webb. But second of all, or I guess the second option here, is to maybe have some kind of a retrieval mission. Basically something similar to what happened with the asteroid Ryugu and Bennu, but in this case really focusing on these very bizarre dark comets in order to find out what's on them, and thus by extension answering the question about Oumuamua. And so until those observations and until those future missions, we're unfortunately not going to know much more. But I'm still going to keep my eyes open for new studies and possibly new discoveries, because this is a really fascinating topic. A completely new type of an object in a solar system that we didn't know existed until relatively recently. And today we're going to discuss some of the recent discoveries about strange objects right here in the solar system referred to as Centaurs. Very peculiar objects that can actually act like both asteroids and comets that all most likely came from the outskirts of the solar system to eventually find themselves orbiting somewhere between Jupiter and Neptune. And because in many cases Centaurs cross these objects, they actually don't have permanent orbits. In most cases they stay here for just a few million years before either getting kicked out or transforming in some other way. But in the last few years, quite a few of these objects have been discovered, and many of them are somewhat strange. As a matter of fact, there are possibly several million of these objects in the solar system, with many of them over 1 kilometer in size. But the largest one discovered so far is this, Chariklo, an object orbiting between Saturn and Uranus, and that's at least 260 kilometers in size. Moreover, a lot of recent observations essentially confirm that it seems to have an unusual ring, and actually even a series of rings whose origin is currently unknown, although we've discussed some of the potential explanations in one of the previous videos in the description. But in the last few months, there's now been additional observations of a lot of different Centaurs out there, uncovering a few more mysteries about them, uncovering their chemical composition, but also potential origin, and a few more clues about the existence of water out there. And so let's discuss some of these new discoveries, and of course talk about what all of this means. And as you can imagine, a lot of these new discoveries and these new observations are really all because of James Webb Space Telescope, the telescope that has now captured several Centaurs and their unusual emissions. And so far the evidence confirms that in most cases Centaurs seem to be chunks of the ancient solar system, or basically leftovers from the ancient solar system, leftovers from the planetary formation that never got to become anything. And though most of them are basically on the outskirts of the solar system, mostly in the Kuiper belt, quite a few of them get disturbed over time and approach the solar system much closer. And because Jupiter is relatively massive, it basically captures many of them, giving them a somewhat unstable orbit between Jupiter and another planet. Although some studies suggested that some of these objects potentially make it closer to the Sun, with Ceres maybe one of these ancient objects that basically survived the passage and eventually ended up in the asteroid belt. But as we're going to be talking about today, many of these objects, as they go through the solar system, very likely transform quite dramatically. Such as for example this Centaur that was recently analyzed, 29P. This object is known for its very unusual, very active, and somewhat periodic outbursts that sometimes can be very intense and last for up to 2 months. This is actually one of the most active objects in the outer solar system, and we've recently discussed this in one of the videos in the description. And in that video we actually discussed a discovery of carbon monoxide mixed with carbon dioxide, but that seemed to be coming from two separate sites in two different ways, which essentially suggested a kind of a bilobal object, or basically a kind of a snowman with two separate pieces very likely containing completely different stuff. And these bilobal objects have obviously been discovered before and seem to be pretty common at the outskirts of the solar system. So basically here, a lot of different objects seem to actually coalesce into larger chunks, with a lot of them staying as a single piece afterwards, but some of them possibly separating and forming two new objects. And this is maybe what happened to Pluto. But we'll talk about this in a separate video really soon, so subscribe and stuff. But then on top of this, there was another observation from a different object known as 39P, an object known as Oterma. And here once again researchers discovered carbon dioxide, but in extremely small amounts. But unlike a lot of other Centaurs, there was no water or carbon monoxide, basically suggesting different chemical composition, and here the difference could be due to the size. A lot of previous observations were of Centaurs in tens or even hundreds of kilometers in size, whereas this one, 39P, is actually less than 5 kilometers. And so due to the size difference, it very likely experienced different evolution and thus contains different material. But some of the most exciting observations were from this study right here that looked at Chiron. Here, Pernilla Alonso and her team analyzed 2060 Chiron that was originally discovered back in 1977 and is also known to contain a ring. And though this is not the largest Centaur out there, it is pretty large, approximately 200 kilometers across. And well, it turns out that Chiron might be one of the most exciting Centaurs out there and seems to be quite special, containing a lot of compounds nobody expected. And so here, during the recent observations by the James Webb, scientists were able to observe not just the emission of the coma, or basically the cometary tail, but also see some of the surface features, because this object is pretty big. And because this is James Webb, we basically have an extremely accurate spectrograph showing us what it contains. And well, here, researchers discovered a lot of different stuff. A lot of stuff that was expected, but also some molecules that were kind of surprising. So the usual stuff like carbon dioxide and carbon monoxide was visible here as well, but they also saw ethane, propane, acetylene, and even methane, which was not seen around Centaurs previously. Although things like ethane, propane, and acetylene potentially has a slightly different origin. Here this didn't come from the early solar system, instead this was very likely the result of oxidation. So basically, as various carbon compounds interact inside this object, and specifically interact with oxygen, they eventually become slightly more complex organic molecules. But methane, though, was a little bit surprising. And in this case, it's believed that this methane is very likely coming from inside through a very peculiar process. And here, to answer the question of its origin, researchers discovered something on the surface. That something was water ice, but not the kind of ice we're used to. There's actually an older video that should be in the description that basically talks about different types of water ice, and actually some of the recent discoveries in regards to some of the more unusual water ice. But basically the ice we're used to right here on Earth is actually surprisingly uncommon out there. And though there are something like 20 different types of ice that can exist, the most common ice that exists out there in the entire universe is what's known as amorphous ice. Also known as the amorphous solid water, that basically, instead of forming very rigid crystals, instead solidifies in a very disorderly state with no regular positions, no orientation, no crystals. And usually this happens when water vapor condenses in extremely low temperatures, such as for example in outer space, making this the most common type of water out there and a major component of a lot of different comets, a lot of solar system bodies, including previously mentioned Ceres, a lot of interstellar clouds, and basically most of the universe, except for, unusually, planet Earth. Ice here is actually unique and somewhat unusual, but unlike ice on Earth, amorphous ice is very porous. It basically has a lot of holes and has a very different consistency, and on top of this, it can also absorb gases, or basically it can store gases for a very long time. And so in outer space, this type of ice very likely represents a source of a lot of different chemical reactions, where many different gases and very different molecules extremely slowly react over time. And so a lot of complex organic molecules we usually see in various nebula or even in various comets potentially was a result of chemical reactions inside of this amorphous ice. And so when it comes to Chiron, because here we observe amorphous ice on the surface, a lot of complex organic molecules, and even methane, it basically presents us with an explanation to what's most likely happening here. All of this methane, carbon dioxide, and even water ice is essentially pristine, very likely 4.5 billion years old or even older, created during the birth of the solar system. But now that Chiron finds itself much closer to the Sun, a lot of this amorphous ice is basically decomposing, and a lot of gases from inside of this ice are now escaping. And intriguingly, the researchers from the study point at this study that kind of confirms how this chemical reaction works. This was recreated in a lab using amorphous ice, but here scientists definitively showed that the emission of methane due to the phase transition in amorphous water ice will very likely result in the cometary tail we usually observe from various Centaurs. It usually happens at specific temperatures around 61 Kelvin. And so here we have a definitive confirmation that Centaurs are basically solar system leftovers with super pristine, untouched materials on the inside. But because they all seem to behave differently and have very different emissions, there are obviously still some unanswered questions in regards to their origin and individual differences. Or basically, why is it that some of them emit certain things in certain ways, and why does every active Centaur we've seen so far seems to be basically extremely unique, at least compared to a typical comet we usually observe, which very often will have extremely similar emissions. But because we're now able to observe the coma and the surface of these objects, chances are that in the next few years we'll finally have some of the answers. And it's obviously really important to study these objects if we actually want to understand how the early solar system evolved and how planets like Earth formed as well. So here's an intriguing question that I guess nobody asked before, or at least nobody investigated scientifically. Of almost 300 moons in the solar system, why is it that none of them seem to actually have any rings? Even moons that should have rings technically, because of, for example, geological activity, or because of the amount of stuff they emit from things like cryovolcanoes. And while it looks like, for the first time ever, someone actually didn't just ask this question, they've conducted a scientific study, potentially provide us with a very intriguing answer. And so, hello wonderful person, this is Anton. In this video we're going to try to answer this question as well, by focusing on a study from Mario Sukarkia and his team with a simple title, The Missing Rings Around the Solar System Moons. And by itself this is an intriguing question, mostly because of what we've discovered in the last few decades, and specifically rings around so many other objects in the solar system. Now obviously 4 of the main planets have rings, but today scientists believe that even planets like Mars, Earth, and very likely Venus and Mercury potentially had rings before too, based on previous collisions with very large asteroids, or in the case of planet Earth, with a planet we call Theia, and that's of course the collision that eventually produced the Moon. But before the Moon, Earth most likely possessed rings as well. And for planets like Mars, it might even reacquire rings when one of its moons gets really close and becomes tidally disrupted by the Martian gravity. There was even a lot of evidence for the past Martian rings explored in the study right here that we discussed in one of the videos that should be somewhere below. Moreover, we know that even asteroids tend to have rings as well. For example, here's a simulation of what we think Chariklo looks like. And well, here too you can see there seems to be a set of rings detected a few years back. Here this was discovered by observing Chariklo pass in front of a distant star, which essentially created unusual dips on both sides that can only be explained by a ring. And even dwarf planets seem to contain them as well. Here's the famous potato-shaped Haumea and the much more mysterious Quasar. And so a lot of different types of objects seem to possess rings for one reason or another. Yet why no moons? With almost 300 moons around various planets, and even more moons orbiting other objects, including objects like Pluto, we expect at least maybe one of them to contain something. Yet so far, there seems to be nothing at all. And intriguingly, this idea was actually started by exploring something entirely different. Back in 2021, there were a lot of studies in regards to the potential discovery of an exomoon, or basically a moon outside of the solar system, known as Kepler 1625 b1. Here this was some kind of a giant exoplanet that several studies proposed contained an exomoon. But not just any exomoon, a giant exomoon, with a mass close to Neptune, at least based on its size. And though this discovery is still kind of controversial and has not been officially confirmed yet, If correct, it would suggest an existence of an unusual giant moon that seems to defy expectations. But in 2021, the team behind this recent study proposed something else. They actually proposed the idea now known as chrono moon, from the Greek chronos, for Saturn, because of what they might contain. And so here the explanation was that this was not a large moon, this was actually just a moon containing very large rings. And so because of these Saturn-like rings, it would just appear much larger than it actually is. And here this explained pretty much everything, including the unusual size, without violating anything we know about how moons and how planets form. But there was obviously a small problem. If this chronomoon had rings, and if obviously these rings can form in this star system, here we still have that other question. Why no rings in a solar system? None of the moons in the solar system, even the ones really far away from everything, seem to contain rings. And because there's a lot of raw material everywhere that should allow moons to form rings, this actually was a really unusual mystery. For example, we know that some moons are entirely covered in craters. Well, actually the best example here is our own moon. Lots of craters everywhere. And during these collisions, a lot of the impact ejecta, in theory, should form a ring pretty easily. On the other hand, some moons have a lot of cryovolcanism, ejecting lots of different vapors around itself. Yet here, there's also no rings. And so what's really happening here? Well, one obvious answer is that maybe the planets just have so much gravity that they destabilize everything and are just maybe a little bit too influential for any rings to form around any moon. But this is of course just a hypothesis. To test this though, researchers decided to conduct N-body simulations just to see what they create and if any moons can form rings in the process. And well, it turns out that the simulations here show that rings should be possible. You can actually see them as these unusual gray circles around each moon. But because of the planetary influence, there is a kind of a stability threshold that most moons seem to not meet, which is why so many moons, instead of acquiring their own rings, end up actually forming rings around the main planet. Here's a very famous example of Saturn, and in this case this is the E-ring formed by the particles from Enceladus. Here it ejects various water and ice particles, which basically form one of the rings around Saturn, instead of forming the ring around the moon. And so at least for some of these moons, the answer seems to be pretty obvious. The planet just has too much gravitational pull, or in more scientific terms, the moon is just a little bit too close to the Roche limit of the host planet. But some moons, like here we see Mimas, in theory are in a location where they should be able to have something, some kind of a small ring or something resembling a ring. Yet here, as you can see, no rings either. And so initially this led the scientists to assume that, well, maybe all rings around all moons basically just become unstable over time. But if so, we should have some evidence somewhere. Yet intriguingly, in their simulations, they seem to get a completely different result. The simulations representing millions of years seem to produce structures that seem to be kind of stable. And this is even for moons in somewhat hostile environments that seem to have a lot of neighbors or were orbiting close to giant planets. Intriguingly, in many cases here, a lot of these rings were also somewhat unusually shaped, producing very bizarre, wavy structures and all sorts of patterns that usually are not visible around planets. And so if their simulations suggested that the rings should be possible and should actually be stable, here we once again are faced with that original question. Why is it that in real life we still don't see anything? And well, it turns out that the answer is really simple. Wrong place, wrong time. Or basically we're just observing this at a time when no rings seem to exist anywhere, even though they should. For example, almost 15 years ago, Cassini's spacecraft found unusual evidence of material orbiting Rhea, one of the Saturn's moons. But here the amount of particles suggested that this was just a remnant of a ring and was only detected because the spacecraft passed directly through it. So this was some kind of a debris disk that measured several thousand kilometers, the last remnant of any ring around any moon in the solar system. Likewise, we know that the Saturn's moon Iapetus has a very unusual ridge running along the equator that appears as if something fell on top of the moon and basically resembles some kind of a ring remnant. And this by itself is actually not surprising at all, because this is exactly what's happening to Saturn itself. Technically, we're super lucky to see rings of Saturn, because this is an extremely temporary event. Here the rings themselves are slowly dissipating into the gas giant, and are going to be completely gone in millions of years in the future. And so here the conclusion from the study is that, well, we seem to have gotten lucky with Saturn being able to see its moons, but we just got unlucky with the moons. All of the moons have either lost their rings or have not reacquired rings yet, with only one moon in the solar system, Rhea, showing signs of a remnant still in its orbit. But because there's so much pressure from the Sun, so much interaction with additional moons nearby, and the planet itself, and even things like magnetic fields, all of this eventually breaks apart in a ring until it's replaced by something else in the future. And so scientists behind the study are pretty convinced that in the past, billions of years ago, quite a lot of moons very likely had rings, and possibly even most moons, mostly because of the way they can form through various collisions with, for example, a large asteroid. And so naturally here this suggests that quite a lot of rings very likely ended up on the surface of various moons, with I guess only one moon, Iapetus, showing distinct visible signs. But here the more interesting question is, what about our own moon? The assumption here is that it also had rings at some point, but it would be very interesting to find out what happened to its remnants, and did it mostly end up on the surface of the moon, or landed on planet Earth. And so at the moment we obviously have no additional answers, but at least we have an answer for this somewhat intriguing hypothetical question. So why no rings around the moons? We're just looking at it at the wrong time. And today we're going to discuss some of the recent discoveries about the mysterious Oort cloud, an enormous cloud of a lot of different icy planetesimals that seems to surround the solar system on all sides, and that seems to extend to a tremendous distance of almost 3.2 light years. But specifically, we're going to discuss some of the recent studies that basically discover something really unusual about its shape and potentially redefine our understanding of what seems to affect this cloud and how it seems to interact with various inner planets and the galaxy itself. And so let's talk about some of these discoveries in a little bit more detail, but I guess first just a little bit of history of what we know about it and how this was found. And while technically Oort cloud is also known as Opic cloud, and that's because of this wonderful person, Ernst Julius Opic, an Estonian astronomer who was basically very prolific in the early 20th century and who is really famous for two very specific things. The concept known as the Europe effect, or basically the effects the sun has on a lot of asteroids as it moves them around and makes them spin much faster, and a very early proposition based on a lot of different observations of various comets, that there actually seems to be a reservoir of these comets somewhere on the outskirts of the solar system, where most of them seem to be coming from. Especially the comets we refer to as long-period comets, like the one you see right here, the famous comet Halley. And he was able to propose this back in 1932, even before we had powerful telescopes. But his idea was then revived by the Dutch astronomer Jan Oort, who was trying to resolve a somewhat unusual paradox. The paradox being that we know comets tend to disintegrate as they come close to the sun, so they could not be possibly orbiting the solar system for more than a few thousand years. And so a lot of them must have been coming from somewhere, because they could not be formed in their current orbits. But here he actually applied an extremely detailed study using orbital parameters of many different comets to discover that a lot of them potentially have their aphelia, or the farthest point in their orbit, at a distance of approximately 20,000 astronomical units. Or to be more specific, he reasoned that their orbit was not parabolic, as in they were not coming from outside of the solar system, but was actually just extremely eccentric and was basically an ellipse. And because eventually this proposition was accepted, this area, or this reservoir of comets, was eventually named in his honor, Oort cloud. But basically everything we know about it is essentially theoretical. It's never been physically seen in the solar system, and we've never seen any objects at these distances. Here we're talking about distances from the Sun of 1,000 to approximately 100,000 astronomical units, or maybe even as far as 200,000. And so the shape of this cloud and everything we know about it is basically based on theoretical predictions and simulations. But based on these predictions and simulations, we know that it seems to contain at least two main parts. There is a somewhat disc-shaped inner Oort cloud, also known as the Hills cloud, named after the American astronomer who was able to predict it and explain it back in the days, and a much larger spherical cloud, or the outer cloud, that wraps around the sun in the way you see right here. Here the radius of the sphere is at least 2 to possibly 3 light years. And so here you can actually see that the tiny blue spot in the middle, that's basically the famous Kuiper belt. the only outer region in the solar system that we physically observed previously, and where we have a few probes like the Voyager probes or the New Horizons mission that are slowly moving away from the Sun. But in comparison, the Oort cloud is much farther away and of course much larger. It extends way beyond heliosphere and is technically inside the interstellar space, and thus receives a lot of effects from a lot of passing stars and even the galaxy itself. We'll discuss some of these effects in a few seconds. But essentially, based on the analysis of various comets coming from this region, scientists in the past have been able to estimate the approximate mass of this whole object and of course the distance between various objects. And the current estimates suggest that there are probably trillions of different objects, at least 1 kilometer in size, which is a pretty normal size for a typical comet we observe in the solar system, and billions of objects larger than 20 kilometers, which would be a very large comet, and is thus a lot more rare. If you actually add up all of them, you get approximately 5 Earth masses in total. Several masses of planet Earth orbiting on the outskirts, but objects mostly made out of various ices, and things like carbon dioxide, carbon monoxide, and methane. And though obviously we cannot see these directly in the solar system, some of the previous observations from the James Webb, like the ones we've discussed recently in one of the videos in the description, basically show us how this particular area seems to have formed and what it's mostly made out of. This is the famous object known as Herbig-Haro 30 that we discussed in that video in the description. And so here this is a baby star where the Oort cloud is still forming, and it's basically forming as a result of the interaction between massive objects very close to the star, scattering a lot of different particles into outer space, where they then form large objects as well. And though by itself this Oort cloud seems to be kind of populated and obviously contains trillions of objects, in terms of individual distances, there is a lot of space between each of these objects. As a matter of fact, before they become comets, the separation between each of these objects is potentially at least 1 astronomical unit, the distance from Earth to the Sun. And so even though this might look crowded, there's a lot of empty space in between. But even though a lot of these objects have been here for over 4 billion years, many of them have been disturbed over time and eventually return to the inner solar system to either become comets and eventually be broken apart by the Sun, or to possibly even collide with something, like for example whatever happened here on Ganymede, or the famous collision with Jupiter of the comet Shoemaker-Levy 9 that was witnessed a few decades back. And in the last few years there's actually been a few studies trying to figure out what exactly causes the disturbance, and if any of the collisions on planet Earth possibly came from this region as well. And interestingly, in one of the studies in the description, scientists actually did discover that at least a few meteors potentially had bizarre hyperbolic paths, with the trajectory suggesting that they came from the Oort cloud. Now here we're talking about relatively small pieces, basically something that's less than 1 meter across, but at least 4 objects have been discovered in the data from the last 5 years. With the conclusion from the study basically being that if we discover some kind of a hyperbolic meteor, there's actually a really high chance it came from the Oort cloud and not from the outside of the solar system. You can learn more about all of this in the study you see right here. The link should be in the description. But then the question is, what actually causes these objects to change the trajectory and to eventually enter the inner solar system? Well, here there is no one answer, but we know for a fact that nearby star passages seem to produce some of these effects. And so in a different study that you can also find in the description, there's actually an entire list of different stars that passed near the Sun in the last million years or so, and also stars that are going to be passing near the Sun in the near future. But the most well-studied and the most well-known star is the famous Shoals star. The star that passed through the Oort cloud 70,000 years ago, and whose disturbance most likely has not been felt yet. Essentially all of the rocks it disturbed are probably still on their way toward the inner solar system, mostly because for most of them, it very likely takes a super long time to travel. Just to give you some perspectives here, one of the fastest space probes out there, Voyager 1, is only going to reach Oort cloud in approximately 300 years. By then, it's no longer going to be functional. But it's actually going to take 30,000 years to pass through this cloud, despite its relatively fast velocity. And so a lot of cometary objects that were disturbed by the Shoals star are still going to take thousands and thousands of years before they enter the inner solar system. Likewise, in some of the previous videos in the description, you can also learn about the next passage that's going to very likely disturb the Oort cloud again. That though is not happening for at least a couple of million years. But the conclusion here was that typically we can expect some kind of a disturbance from a star every few 100,000 years. Which is of course why we're seeing so many comets in the inner solar system, because many of them were disturbed millions of years ago. But turns out, passing stars is not the only disturbance, and possibly is not even the main disturbance, because as the scientists in the most recent study discovered, not only is the galaxy itself seems to play a much bigger role, turns out we might have been actually incorrect about the shape of the Oort cloud, because the galactic tides very likely created something that's not a sphere. And instead, the Oort cloud very likely resembles something like this. It's essentially an S shape, or something that resembles galactic arms. And that's of course the most recent discovery. So here, the study by David Nesvorny and his team used the NASA's Pleiades supercomputer to create a very powerful simulation of the debris field of this virtual solar system that was being formed from scratch. And so essentially here they simulated 4.5 billion years of the solar system, but with one main difference compared to previous simulations. They applied external gravitational effects from the Milky Way galaxy itself and the tidal effects that it produces on various stars. And as the simulation was being run, instead of forming a sphere and a torus like what we usually see in some of the previous images, in this case the inner region that was believed to be a torus, and that's actually believed to be very stable and tends to be not disrupted by passing stars as much as the outer region, here this flat torus disappeared completely, and instead we got a spiral structure. In other words, in some way this actually resembles a typical spiral galaxy, with the entire disk measuring approximately 15,000 astronomical units, but also being inclined by approximately 30 degrees, or suggesting that the flat toroidal disk might not exist at all. But more importantly, they discovered that not only was it actually there for at least 4.5 billion years, or it basically formed almost right away, it's also surprisingly stable. In their simulation, it survived for over 4 billion years and only changed the shape a little bit. And that's despite interactions with other stars or additional orbits around the galaxy. But there's obviously one problem here. Right now this is still based on theory and simulations, and is not based on direct observations. And even though technically observational data from previous comets seems to suggest that this could be possible without physical observations from the solar system, or at least seeing this in some other star system out there, we're not really going to be able to confirm this. And trying to observe this with current technology is still a little bit difficult. But the thing is, it's actually quite possible. As a matter of fact, it's not the first time the shape of the solar system was redefined through observations and simulations. For example, in one of the older videos we discussed how the shape of the heliosphere, that was always believed to be kind of cometary in shape as well, turned out to be entirely different and basically resembled some kind of a croissant or some other strange pastry. And this was actually physically confirmed later on after the simulations discovered that the shape might not be cometary or spherical. And so something similar is possibly going on here. We just need to find a way to physically confirm this through observations. And I guess right now the best hope is James Webb. Hopefully in the next few years we might be able to observe some other star somewhere out there whose Oort cloud might become visible and reveal its true shape through some very specific observations. As far as I know, it has not been done yet, and so at least for now all of this is going to remain purely theoretical. And in this video, we're going to be discussing a somewhat unusual discovery of an object we've known about for practically 2 decades, but that turned out to be maybe a little bit more mysterious. The object you see right here known as 148780 Algira, a type of an object we refer to as KBO, or Kuiper belt object, with obviously Pluto being the largest of such objects, but that in this case actually seems to be somewhat more mysterious because even though we thought it was a binary, with each of the objects approximately 200 kilometers across, it's actually, possibly, a triple system. In other words, it seems to be a little bit more mysterious and actually adds to the mystery of how a lot of these objects seem to form, because quite a few of these objects have been discovered in just the last few years. And so let's discuss this in a little bit more detail, but also discuss some of the problems I have with the way this was presented to us through the press release by NASA, which I'll mention in the end. Because here, let's actually start with the discovery and with what all of this means. So first of all, this is pretty far away from us, approximately 45 astronomical units. And here we have these 2 icy objects that were collectively named Algira, named after the god of creation from an Aboriginal culture in Australia. And as I mentioned, these objects are not small, they're actually pretty large. The distance between them is approximately 7,600 kilometers or 4,700 miles, and each of these objects is over 200 kilometers in size, or approximately 150 miles. And because these objects have been observed for a relatively long time, we actually have data from back in 2001, here it became possible to study their orbit super accurately. And well, eventually, through these observations, researchers discovered something somewhat unusual. There was a bit of a deviation, as if something else was in the system. And so in this new study, Maya Nelson and the team from the US, in essence confirmed that there was an unusual orbital deviation pretty much every year, as if something was shifting these objects just a little bit. And that was somewhat bizarre because previous observations, especially observations of the albedo or reflectivity of these objects, pretty much confirmed that these objects were almost entirely spherical, which meant that they should have had very stable and almost perfectly circular orbits. And while the only explanation here that kind of, I guess, made sense was that this was not a binary system, this was a hidden triple system. A kind of a cosmic triplet, where one of these objects was actually two objects. And though unusual, this is not unknown to us. As a matter of fact, in the last few years, at least one other similar system has already been discovered. You can actually see it right here. This is known as the Lampo triple system, which in essence is three separate objects, very similar in size to Algira system, that seem to also appear binary, but actually act like a triple system. And this has been officially confirmed a few years back. And though that was also unusual, now scientists are pretty certain this is actually a lot more common than we thought. And so here, based on 17 years of observations by the Hubble telescope, combined with the observations by Keck Observatory in Hawaii, the new study almost definitively confirms the existence of these bizarre triple systems. And I guess more intriguingly, a very similar system has actually been very recently pictured by the Lucy mission. You can learn about this mission in one of the videos in the description. But near the end of 2023, when Lucy was doing a flyby near an object known as Dinkinesh, completely by accident it discovered this. Dinkinesh didn't just have a satellite, that satellite appeared to be a binary system, or to be more exact, a former binary system that has now become one and is referred to as a contact binary. Something that actually happens quite a lot in astronomy with quite a lot of different stars, and of course quite a lot of different planetary objects. And one of the most well-known and most surprising contact binaries was pictured by the New Horizons a few years back. Here this was the famous Arakoth, that also turned out to be a very similar contact binary, where two objects came so close together that they eventually became one. And so a very similar object potentially exists here, or maybe this is still a binary that will eventually become a contact binary, because at the moment, due to distances, it's just almost impossible to tell. Here, a single orbital shift is just 1 pixel, even in the observations from the Hubble Space Telescope. So this is just a little bit too far for a more detailed observation. But because these gravitational parameters can only be explained if this is a triple system, right now this is the best explanation we have. Which basically means that these bizarre triple objects seem to be way more common than we believed. And they don't just exist on the outskirts, they also exist much closer to the Sun. But the question here is, why? And well, it turns out that because of this discovery, we actually now have a slightly better explanation for how many of these objects very likely formed. Previously, scientists believed that many of them formed as a result of various collisions, but Algira system, along with similar discoveries, actually tell us that this would be almost impossible. Instead, it actually suggests that a lot of them very likely formed through a direct collapse of a lot of different particles over a very long period of time, with pretty much most of these Kuiper belt objects potentially forming directly from the leftover mass and without any major collisions. And because this seems to be the second such system in the Kuiper belt, researchers now want to take a look at other binary systems, because approximately 40 other similar systems have already been discovered. But I guess what's really bizarre is that we've only analyzed and taken pictures of several of these Kuiper belt objects, but strangely enough, a lot of them seem to be this. They seem to be contact binaries, or in some cases, unusual triples. Now obviously this is still very biased, because we've only discovered only like 3,000 Kuiper belt objects, and up to about 1 million potentially exists on the outskirts, but chances are quite a lot of them are going to be very similar to this, unless I guess we get somehow super lucky. But the thing is, until future observations with the James Webb Space Telescope, it's going to be almost impossible to prove if this is indeed something similar to what you see right here in the system of Dinkinesh. Although it might be possible to measure the orbits more accurately, because right now the system goes through a lot of different occultations, and so thorough observations for the next few years might actually confirm all of this once and for all. But once again, because there seem to be so many contact binaries, and so many unusual binary and triple systems, it basically tells us that collisions on the outskirts are very likely extremely rare, with most of the stuff just forming directly through what's known as gravitational collapse. All of this material just coalesced into one without experiencing too many disturbances, even though obviously we can see some craters right there on the surface. And so for all we know, Algira might be somewhat similar to what you see right here, except that I guess 10 times bigger. This is only about 20 kilometers across, the Algira system is over 200. But we'll definitely discuss the system once again once we get new pictures from the James Webb Space Telescope. But before I finish this video, I wanted to also mention something else. And actually something in regards to how this was communicated by NASA through their initial press release. Here, they essentially make it sound like this is an extremely unusual system that's somehow related to the famous three-body problem. The concept that became popularized after a very famous Chinese novel and a very famous TV show. We've actually discussed this in more detail in one of the videos in the description, but in essence, here, this is what a three-body problem would be. Orbiting a center of mass that's constantly shifting, but whose motion is almost impossible to predict because there is really no general way to explain what they're going to be doing. But the thing is, whoever wrote this press release by NASA erroneously refers to this system as a three-body problem as well, and it actually isn't. Because a three-body problem does not have a solution, or at least no general solution, where a single equation could solve everything. In contrast, that's not the case here at all. Because we actually did have a solution in terms of orbital parameters, the only reason scientists discovered that there was a third object is because there were slight deviations in orbit that were also solvable. So this was not a three-body problem at all. And instead we actually refer to these as hierarchical three bodies, or a hierarchical triple system. A system that does have a solution because here the three bodies orbit in a hierarchical way. We have two bodies orbiting each other, and then we have another body farther away orbiting these two smaller bodies, which is extremely common in astronomy. We actually see a lot of these multiple star systems pretty much everywhere. And in every single case, we can predict their orbits, and there are general equations that apply to all of them, which in contrast could not be done with the classical three-body problem. Except for, I guess, some cases. Three-body problem is solvable with special case situations. As a matter of fact, in that last video, we discussed thousands of new solutions that all seem to solve three-body problems. And so, even though it's, I guess, not really a mistake, it's still a little bit erroneous to compare three-body problem from classical physics to what's happening in these triple hierarchical systems. Because in this case, this problem is technically solvable and has been solved. And that's not the first time I've noticed this with a lot of communications by NASA. For example, just over a year ago, I tried to email them asking them why is it that Chandra Space Telescope team was always erroneously reporting distances in billions of light years when they were actually referring to objects whose distances were measured as if the universe was not expanding. Or in other words, they often reported distances as completely incorrect. And there are so many examples, it seems to be actually in every single report, with one of them right here. A report from a galactic cluster that's at a redshift of 0.97 that they claim is 7.7 billion light years away from Earth. Except that it's not. It's almost 11 billion light years away from Earth, and in this case what they're actually referring to is the light travel time, which is 7.7 billion years. And it's actually been bugging me for several months. I even emailed them, with the only answer I got at the end being, I guess we're just doing it because it's easier. And so yeah, in terms of science communication, even NASA team has a bit of a problem. But I guess we'll discuss this problem with science communication in maybe some of the future videos. And today, we're going to talk about some updates and some new discoveries, including some potential new explanations about planet Mercury. And that's because even though we don't talk about Mercury much, we will be talking about Mercury quite a lot in the next 2 years, specifically after 2027, because this is going to be the official start of the Bepi Colombo mission that's going to be orbiting Mercury for many years, collecting lots of data, and finally answering some important questions. We've talked about this mission before, but it's essentially a joint ESA and Japanese Space Agency mission launched back in 2018 and on a track to orbit Mercury by 2027. And the reason this mission is taking so long is really because of its complex orbit. It's technically using a lot of gravitational assists from multiple planets in order to save as much fuel as possible and in order to then assume an orbit around Mercury for several years. And that's actually because technically trying to get to Mercury because of its really high velocity is more difficult than trying to get to Jupiter. And that's the beauty and the complexity of orbital dynamics. You can learn more about this in one of the videos in the description. But this mission is supposed to finally answer many questions we have about Mercury, including its bizarre magnetosphere, its external and internal structure, and most importantly, its origin. Because all of these currently don't make sense. For example, we know it has a magnetic field, and though it's weaker than planet Earth, it's not supposed to exist. Because Mercury is smaller than Mars, and it's also geologically inactive, or at least appears to be so from the surface. So what's actually causing the field is currently unknown. Moreover, a lot of observations from the surface discovered a lot of really dark patches. This was actually seen by the NASA's Messenger mission, and eventually it turned out to be a lot of carbon, and specifically a lot of graphite. And what exactly it's doing here and how it got here is also, of course, a bit mysterious. And so since Mercury looks so bizarre, and is also bizarre on the inside as well, some of the researchers previously suggested that maybe Mercury came from somewhere else. It was possibly formed on the outskirts and eventually ended up near the center. Alternative explanations suggested that Mercury was much larger before, but then somehow lost a huge part of its outer mantle, which eventually resulted in what we see today. This could have been the result of a massive collision that removed an enormous amount of the outer layer, with the biggest mystery just being the fact that it's also more massive than it should be, which of course implies that it has an enormous iron core. It seems to have more metal than it should have, and way more than even planet Mars. But recently, in January of 2025, Bepi Colombo finally released some of its additional images from the surface, basically showing us a lot of beautiful structures once again. You can actually find these images in the description, but this finally shows us Mercury with incredible resolution. And though some of these features we've actually seen before and even discussed before, some of them are kind of new. For example, here we seem to detect bright lava flows that possibly happened billions of years ago. Whereas in this image, we see a feature known as Nathaire Facula, which seemed to be the result of the largest volcanic eruption, and specifically a volcanic explosion, that created a vent 40 kilometers across. So back in the days, this planet was potentially extremely explosive. It also shows us the Fontaine crater, which very likely formed approximately 300 million years ago. And these images are unique because they were taken from the closest approach to Mercury so far. But obviously by 2028, we're going to get even better images, and we'll probably be getting regular images pretty much every week. But going back to its surface and the discovery of graphite, not so long ago, Yongjiang Zhu and the team you see right here decided to see if they can actually find out what's underneath Mercury, assuming that it has composition that we know, or basically assuming we actually combine a bunch of stuff we see on the surface and try to create conditions similar to what Mercury was like in the first few 100 million years. So basically they focused on a primordial graphite crust and assumed that back then the planet was probably more or less molten. And as a result, they discovered something somewhat surprising. Here this was actually done as an experiment by mixing different compounds known to be present on Mercury, and included things like sulfur, titanium, aluminum dioxide, and then placed inside a carbon-rich graphite anvil press under ridiculous pressures of 7 gigapascals and temperatures of 2000 degrees Celsius. And so this would be Mercury approximately 4 billion years ago. And turns out that in their experiment, this ended up producing diamonds. Or actually a layer of diamonds that, if real, would be possibly several kilometers thick and hidden underneath Mercury's crust, and possibly pretty deep, hundreds of kilometers below the surface. And so essentially this experiment suggests that because there is so much graphite on the surface, there is also probably a bunch of diamonds, really massive diamonds, at least 200 meters thick, and possibly representing at least 1% of the entire planet's mass. But naturally, possibly no way to extract them just because of the depth and because this is also a different planet. But still, a pretty cool experiment. But here there's actually an assumption that Mercury did not change much ever since its formation. And a more recent paper kind of questions this because they tried to explain all of these mysteries, including of course the enormous iron core, in a completely different way. Well, basically through a collision. And so in this study, Patrick Franco and his team decided to see if they can possibly recreate Mercury through various computer simulations by using very specific collisions. But collisions with objects that we know can easily form in the early solar system. And these collisional simulations are pretty common. This is actually how we explain the formation of the moon, when billions of years ago, an object referred to as Theia collided with primordial Earth. And though not everybody accepts this explanation today, it's still the best explanation for why the moon and Earth exist. And so something somewhat similar was now applied to Mercury. And the thing is, this technically kind of makes sense because we know that pretty much all planets in the solar system experienced collisions in the past. For example, a collision on Venus could explain some of the features here as well. I believe there's an older video in the description talking about this. Likewise, Martian dichotomy, or the fact that the south and the north part of Mars are so entirely different, has also been explained as a potential collision on the northern plane of Mars. The north here is actually very squished, and so collision was possibly one of the best explanations. And of course, the fact that Uranus orbits on its side has also been explained as a massive collision back in the days. And so, why not Mercury? As a matter of fact, Mercury, because of its proximity to the Sun, could have experienced even more collisions. And so that's basically the focus of the paper. But in a lot of earlier studies, the impacts were mostly either a kind of a grazing impact, or basically involved a collision where just the outer shell of the planet was stripped from the object. Here though they did something different. They assumed that these were very similar large objects, possibly colliding almost face-on, or basically in the way you see right here. So the assumption in this study was bodies of similar size and mass, and bodies not so different from the hypothetical Theia that collided with Earth. So basically a kind of a primordial planet. Now we know that Theia was very likely similar to Mars, or about 0.1 Earth masses. And so for this study, researchers tried to do different masses and try to see if they can actually change the velocity of collision and the angle of collision, eventually discovering a simulation where they actually did create something super similar to Mercury. And here it had to be a planet of approximately 5.5% the mass of Earth, but the core, the iron core, had to be really large, 70% of the mass. And that was of course the difficult part. And so in their simulation, by using a primordial object that was about 0.13 Earth masses and contained a 30% iron core, or technically having two of these objects, they managed to recreate a collision where Mercury was formed with extremely similar composition that we expect. As a matter of fact, the overall collision was not so different from the one that created the Moon. And here the remnant matched Mercury's current mass within just about 5%. But most importantly, it had a very large iron core fraction, anywhere from 0.65 to about 0.75, which was very close to 0.7. In other words, by using a simulation here, they managed to prove that it could have been a head-on collision between two larger objects that ended up producing Mercury in an extremely similar way to how a similar collision created the Moon when Theia collided with early Earth. Now here this was just one simulation out of many, but it definitely shows us that this is a very likely and very possible scenario. And since we know these protoplanetary collisions were extremely common early on, here this is possibly right now one of the best explanations. Which would also suggest that objects like Theia, or basically objects about 0.1 Earth masses, might have been super common and might have been actually colliding with a lot of things out there. And one of these objects that only had a minor collision potentially ended up as Mars. And so definitely an intriguing explanation, and something that hopefully Bepi Colombo will be able to either confirm or disprove in the next few years. And so starting in 2027, there's a big chance we'll be talking about Mercury quite a lot. And there's also a big chance that within just a few years, most of its mysteries will be solved because of these super accurate observations. And if this planet was created by a collision, there's a very big chance Bepi Colombo will find evidence. And it's about time we talked about Uranus, one of the more mysterious planets in the solar system, and a planet that we haven't discussed in quite a while. And I actually wanted to start here because here in Space Engine, you can actually easily visualize its beautiful rings as well, which are normally very difficult to see and were only visualized much better a few years back when the James Webb was able to detect them in the infrared light. And so today we're going to discuss some of the recent discoveries about this beautiful planet, including some of the potential solutions to the mystery of its magnetosphere, which also led to the discovery of potentially an enormous ocean underneath, as well as a discovery from its moon, Ariel. And the thing is, because this is a relatively distant planet, and because it's a planet we haven't visited since the Voyager probes, there is still not much we know about it, because even modern telescopes cannot really see it very well. But in the previous video you can find in the description, we'll discuss some of the major discoveries, including the discovery of one new moon, the confirmation of infrared aurora that seem to be present in its atmosphere, and new insights into its magnetic field as well. And intriguingly, it was really the aurora in this case that allowed scientists to discover something entirely different about Uranus in one of the recent studies. This was a study you see right here and you can find in the description, but in essence it's a measurement of Uranus's rotation. And when it comes to its rotation, our previous calculations were based on the observations from the Voyager 2. Here, one day was believed to be about 17.24 hours long. This was actually based on the observations of radio emissions from the aurora, with the measurements conducted by the Voyager probe during its flyby. But using Hubble Space Telescope, it now became possible to also observe the ultraviolet aurora, which allowed for a much more precise calculation of the rotation period. And it actually turned out to be a little bit different. Not by much, but by a few seconds. It's basically at least 28 seconds longer than previously believed, with some media sites unfortunately reporting this as a day at Uranus just got 28 seconds longer. That's not what happened, of course, but nice try, I guess. Nevertheless, here this new technique allows the scientists to now accurately measure rotation of distant planets, which can also possibly be applied to many different brown dwarfs and gas giants in other star systems as well. Although in this case this was based on approximately 1 decade of observations, so this is not something that can be done pretty quickly. But a much more interesting discovery is actually in regards to its magnetosphere and some of the explanations based on new modeling. And this is of course all based on that really old mystery. During the Voyager flyby, one of the strangest discoveries was of course the fact that the magnetosphere on Uranus and also Neptune was not really bipolar. As in compared to Earth, Jupiter and Saturn, where the magnetosphere is dipolar, meaning that they have north and south poles, here both Uranus and Neptune were discovered to have a strange maze of different poles and didn't seem to contain north or south, instead containing a strange set of lines that seem to be all over the place. Here's one of the more accurate illustrations showing us what this looks like. And for many years it was unknown exactly why this is so, but eventually scientists realized that it's most likely because, unlike Earth, where the magnetosphere is generated inside the metallic core, in Uranus and Neptune it seems to be generated by the mantle. And its mantle is made out of different stuff. It's not made out of rocky stuff like on Earth, and is instead potentially contains things like methane, water, and ammonia. So basically here it contains what's known as an icy mantle, that on top is covered by a huge atmosphere as well. And so in this recent study, researchers were actually able to work out a model that actually seems to explain pretty much everything, in the process discovering something else unusual about Uranus that we're going to be discussing right now. Basically here, because of the really thick atmosphere, that's about 4,000 to 5,000 kilometers in thickness, we have this really hot and highly pressurized icy mantle, where everything sort of gets separated into layers this way. Basically things like methane and things like ammonia potentially start to form something a little bit different and create a kind of a stratified carbon-nitrogen-hydrogen mixture on the bottom, right above the solid rocky core, with what seems to be a really huge water mixture above it. And it's really this water-hydrogen mixture that's potentially responsible for the magnetosphere. In other words, underneath the hydrogen-helium mixture that forms the atmosphere, because of the pressure and the temperature, the icy mantle seems to form something entirely different from what was previously believed. This compressed water forms a hydrogen mixture, and methane and ammonia basically become something a little bit different as well. And in some sense, this unusual stratification is kind of similar to what happens when you mix oil and water. They basically form two separate layers. Now here we don't really know how many layers form, but because of this unusual separation into oxygen range layer and carbon-nitrogen layer, this would very likely now create convection. And in this case it's the convection inside this water-hydrogen layer. And because this water is essentially ionic in nature or contains charge, this convection then creates magnetosphere, whereas the carbon, nitrogen and hydrogen layer below it do not seem to produce any magnetism and stay more or less insulated, with all of this basically being the result of extreme heat and extreme pressure. And because this water-rich layer seems to be at least 7,000 to 8,000 kilometers in thickness, it results in a huge convection layer and thus produces relatively powerful fields, but also fields that are somewhat hectic and possess multiple poles as opposed to just one, which to some extent explains the observations from the Voyager probes. And naturally, if this is correct, it does present the slightly different view of what seems to be happening inside these unusual giants. And so basically here both Uranus and Neptune seem to contain a somewhat smaller rocky core. For Uranus this is just a little bit smaller than Mars, for Neptune it's somewhat similar to Mars, followed by a stratified insulating layer containing carbon, nitrogen and hydrogen mixture, and then an enormous ocean, possibly some of the largest oceans in the entire solar system, 7,000 to 8,000 kilometers deep, containing charge and moving around, which results in an electric current that then produces the magnetosphere. And intriguingly, some of the previous studies, usually focusing on exoplanets and planets we refer to as mini-Neptunes, tried to explain some of them as potential humongous ocean worlds containing superheated ionic water that would not be so different from this. And so in some sense, the simulations and the modeling from this study kind of actually connects to these studies as well. And for all we know, maybe this is indeed what happens inside various Neptune-like planets, and these enormous ocean worlds seem to be pretty common. Although without actual experimental evidence, or without probing Uranus, we're naturally not going to know if this is actually correct. Nevertheless, a cool proposition, and definitely an intriguing explanation. You can learn more about this in a study by Burkhard Militzer that you can find in the description. But intriguingly, even without proofs, the studies about Uranus and Neptune seem to still be possible based on observations from, for example, Hubble. And specifically because Hubble Space Telescope has actually been taking pictures of both planets for practically 2 decades. And we now have at least one study focusing on changes in the atmosphere based on dramatic shifts and changes along the poles and along the equator. Now in this case, because the atmosphere on top is mostly hydrogen and helium, the actual observable differences can only be seen through trace elements such as ammonia, water, and methane. As mentioned before, these are mostly underneath, but since they also mix with the atmosphere occasionally, we do see some small amounts here and there. And it's actually methane in this case that gives both Uranus and Neptune its somewhat unusual cyan color. This is because methane absorbs red colors, but not green and blue. And so here, by observing Uranus for 20 years, and specifically focusing on the 4 years you see right here, scientists discovered something that seems to happen on Uranus that does not happen on other gas giants. Here they actually compare this to Saturn and Jupiter, where we know mostly everything seems to be equally mixed, and even trace elements are usually equally distributed. But strangely enough, this doesn't seem to be the case on Uranus. For some unusual reason, methane seems to be completely depleted near the poles, and this depletion stayed relatively constant over the past 2 decades. And so even though at first it was believed to be maybe some kind of a seasonal change or climatic change, this doesn't seem to be the case. Here the poles seem to have no methane. And on top of this, even the hazy aerosol structure changed in the last 2 decades as well. And this is because right now it's going through seasonal changes. 1 year on Uranus is 84 Earth years. And so these 20 years basically just show us 1 season. And specifically this is only showing us the northern spring. And since Uranus is also a tilted planet where it essentially orbits basically on its side, here the change is actually quite extreme. The sun moves from shining directly over Uranus' equator to basically shining over its north pole that it's going to start doing in 2030, which scientists are super curious to observe because this will probably lead to some dramatic shifts. And because Uranus is the only planet that orbits on its side, it's quite likely that the seasonal changes here are going to be entirely different from Neptune. And so here we have observational evidence that solar radiation seems to change the presence of aerosols in the atmosphere of Uranus, with the North Polar region brightening in these 2 decades, essentially suggesting that for some reason these hazes seem to grow larger as the atmosphere on Uranus warms up. And though previously Uranus was more or less featureless, it now seems to contain a lot more banded layers, especially close to the equator. But obviously, since the seasonal changes here are going to be really slow, here it will take us a very long time to understand what's happening, because we really just have these 20 years of observations. And so unless there is some kind of a probe in the future, or unless we literally stare at this object for the next 64 years, at least for now, when it comes to its atmosphere, everything else is just going to be a mystery. But since we're talking about Uranus, let's discuss one of its moons as well. And here it was very difficult to avoid any more butt jokes, because a lot of things that were mentioned in this particular study were almost begging to be made into a joke. But yeah, it's about spreading centers from locations such as Brownie Chasm, or technically Chasmata because it's a little bit smaller. And yeah, I'm not even kidding, this is exactly what they're called. So let's talk about these spreading centers and what this potentially means. Well, the actual study is really about the surface of Ariel that contains many of these very deep chasms, some large, some small. And turns out that the small ones seem to be spreading. Actually, one of the more recent discoveries, and one of the more unusual discoveries, found that many of these grooves also contained a lot of pristine new material, things like carbon dioxide and carbon monoxide, but all deposited relatively recently. and a lot of these carbon deposits were actually believed to potentially come from within, implying that either there is some kind of a bizarre chemical reaction happening somewhere inside the moon, or more likely, since these spreading grooves resemble something that happens inside oceanic crust on Earth, this could only be explained by several potential scenarios. First of all, this could be due to some kind of an underground ocean that seems to create convection cells underneath, which then causes the surface to basically split, while also releasing a lot of carbon materials from inside. Alternatively, this could be the result of tectonic activity, maybe somewhat similar to plate tectonics, but obviously not as complex, whose true origin is obviously unknown. Now, it could be the result of the interaction with neighboring moons, but it could also be the result of something entirely different. Either way, because these features seem to show signs of spreading and growing, this is definitely a really exciting discovery, and once again suggests we should definitely send a probe to Uranus, possibly focusing on its moons, because right now they do have a really high chance to contain something super exciting inside. You can learn about these discoveries in a study by Chloe Bedingfield and her team on Ariel's spreading centers. Yeah, I'm not even trying at this point, these jokes write themselves. And honestly, it's actually kind of surprising that none of the space agencies so far proposed any mission to either Uranus or Neptune for the next few years, because both of these objects haven't been explored since the mid-80s, and both of these objects are super mysterious and are potentially really exciting. Being able to discover what's actually hiding on one of these moons, and possibly learning more about these Neptune worlds, will actually teach us about so many other exoplanets, because so far, as mentioned in previous videos, most of the exoplanets discovered seem to be super similar to one of these. They're normally much smaller in size, but in terms of composition and structure, they're very likely extremely similar. And so hopefully in the next few years, someone makes one of these missions happen. So this is kind of strange, but the last video I made about Planet 9 was actually exactly 1 year ago. And that's because back in May of 2024, we've discussed one of the most recent studies that seems to have discovered even more hints for why Planet 9 might be real after all. This was new, strong evidence, based on orbits of various trans-Neptunian objects, that basically hinted that even though this planet isn't visible right now, it's still somewhere out there. And well, hello info person, this is Anton. Today we're going to discuss a relatively new study that was just released a year later, that potentially discovers one of the possible candidates, and maybe even the best candidate, that was finally identified in a study using infrared data from older telescopes. And so let's discuss this recent discovery that could be groundbreaking if it's true, but also talk about some of the previous discoveries in the last few months. But first, super brief history of Planet 9 and why we think it exists. Here the story starts in 2016. Two astronomers from Caltech presented evidence that some of the distant objects orbiting past Neptune seem to bunch together in a somewhat unusual way, suggesting something was pulling them and changing their orbit. And they were actually far enough from Neptune for this not to be Neptune, which basically became this hypothesis referred to as Planet 9. And over time, there's been a lot of different discoveries and a lot of different hints of its existence, including observations from other star systems that actually contained somewhat similar objects. Here's actually one example from HD 106906. And so if this planet was real, it could actually explain a lot of things about the solar system, including various tilted orbits of different objects that orbit past Neptune, while also explaining certain other orbits that make no sense otherwise. For example, objects orbiting in the opposite direction of everything else that would be somewhat difficult to explain unless something affected them gravitationally. Likewise, if this planet was real, it would finally present us with a type of a planet that we're actually missing. Because here, the solar system, compared to a lot of other systems containing exoplanets, does not contain any mini-Neptunes, does not contain super-Earths, despite containing planets like Jupiter and Saturn, and mini-Neptunes and super-Earths are actually the most common planets in the entire galaxy. Yet somehow the solar system has none. But the proposed mass and size for Planet 9 would actually technically make it either a mini-Neptune or a super-Earth, thus making the solar system just another star system out there. And so in the last few months there's been quite a few additional studies trying to discover this planet somewhere out there, or trying to refine its potential orbit. For example, one of the most recent studies was a targeted search for Planet 9 based on the assumption that certain asteroids and certain meteoroids might have actually been influenced by Planet 9, and so we can actually use their orbit to potentially determine where it is. Like before, the study finds nothing. Then we had the additional very extensive survey by the original authors that tried to look for Planet 9 using a very large survey of various stars, and nothing discovered here either. Basically, none of the objects in the survey appear to be similar to the expected Planet 9. And though some additional recent studies tried to rework its orbit and even its potential mass and size, we still don't seem to find anything anywhere. With some studies even suggesting that maybe it actually left the solar system a long time ago. Basically, it did influence certain objects, such as for example Sedna, and then got kicked out or captured by another star. We've discussed this proposition in one of the videos in the description, with some of the biggest studies actually suggesting that maybe this is all just a type of a selection bias, basically based on the way that we actually observe objects and based on the way that certain telescopes see things. Here, it does actually appear like something is pulling on these orbits, but in reality this is just based on the selection of these objects, and if you actually collect more data, this entire idea of a planet pulling on something kind of disappears. And this was actually a pretty big study from a few years back that we also discussed in one of the previous videos. And so in reality, even after I guess 9 years now, we still have no idea if this planet is real, if it really exists somewhere out there, or if its effects are actually effects, or just basically bias. But now we have this new study by Terry Longfang and the team you see right here that makes this somewhat unusual and somewhat unexpected new discovery. And a discovery based on observations from much older telescopes, infrared telescopes that conducted full sky surveys back in the days. And so here's what researchers did in this study and what they actually discovered. First, they used the data from IRAS, Infrared Astronomical Satellite, launched back in 1983. And this was the first ever infrared telescope, sort of like the grandfather of the James Webb. This was a very successful mission, and it only lasted for about 10 months, but it was able to create an extremely beautiful image of the entire night skies in the infrared, while also discovering tons and tons of different objects. And this was also the start of the infrared astronomy as a kind of a separate field. But then, a few decades later, Japan launched their own version. This is a telescope known as Akari. This was a collaboration between Japan, Europe, and South Korea, and it was a much more powerful infrared telescope that collected data between 2006 and 2011 when it suddenly broke down. But before it broke down, it was able to do something very similar. An all-night sky infrared image with tons and tons of new objects. But because there were approximately 23 years between these two missions and between these two infrared maps, it actually presented astronomers with a really intriguing technique. You could now compare these two night skies and discover certain differences that could be caused by slow-moving objects. In other words, by comparing these two images, it actually became possible to detect certain objects that were moving super slow, which is exactly what's expected of Planet 9 as well. We do expect it to move very slowly across the night skies, with its orbit potentially taking thousands of years. And so in this study, researchers did just that. They basically took two maps separated by 23 years and tried to find every single candidate that moved just a little bit across the night skies. Specifically moved from the IRAS position to a Akari position, but not enough to be a distant star, and also way less than a typical comet or an asteroid. Likewise, because these observations in the infrared, researchers were actually looking at natural emissions from the object, meaning that this object had to be glowing and had to have certain mass. And turns out that initially they found 13 different candidates. But eventually this was narrowed down to just one, the candidate that you see right here, and the candidate that was detected by both telescopes and moved just a little bit, as predicted by different models. And so the question is this actually Planet 9? Well, unfortunately, we don't know, and it's going to be extremely difficult to tell exactly what this is, and here's why. In order to determine if this is Planet 9, we have to know the orbit of this object very well. But here we only have 2 points. With 2 points, it's almost impossible to determine the exact orbit, and it will take years and years of additional observations to find out where this object is actually going. Likewise, we also have to understand exactly what we're looking at here and why we're even seeing this. Here the assumption was that this object was about 500 to 700 times the distance of Earth to the Sun, or basically 500 AU in distance. And the mass was assumed to be 7 to maybe 17 masses of planet Earth, making it somewhat similar to Neptune. But previous predictions, including some of the most recent predictions, suggested that the mass here must be at least 3 times less. maybe 3 to 5 Earths, and not more than that. So we already have our first discrepancy. On top of this, some of the previous studies actually did not detect anything in these surveys, even using similar telescopes. And so the only reason this object was detected by the researchers from this study is really because they assumed that the planet here would be more massive than Neptune, or at least produce more emissions than Neptune, suggesting that it would be just a little bit hotter. Because anything less than 10 Earth masses would not actually produce enough flux or enough emissions to be visible to these telescopes at these extreme distances. This was one of the conclusions from the study as well, with researchers basically highlighting that whatever this is seems to be pretty massive. And so just to summarize, right now nobody actually knows exactly what this is. It could be Planet 9, but it could also be an entirely new object we never knew existed, possibly representing some kind of a massive object somewhere out there. And though it could be a planet in the solar system, at the same time, it could also be some kind of a rogue planet somewhere much farther away with a much higher mass, but basically moving across the night skies pretty fast. And so here, we don't really know if this is a close object moving slow or far object moving really fast, or if this is an object at all. For all we know, maybe this is also some kind of a statistical anomaly or some kind of a data artifact that only future analysis and future studies can determine. Either way though, this is definitely a super exciting new discovery. Assuming that this is a real object, it's definitely something that now has to be observed by other telescopes, including maybe the James Webb, because the James Webb will definitely see this very well since this is all in the infrared. On top of this, some of the instruments used for the optical telescopes, like the ones used in the Dark Energy Survey known as DESI, are sensitive enough to maybe not just see this object, but even determine its exact orbit, because some of the older data might have already captured its motion, helping us figure out how it's moving. Which means that maybe, in the next few months, we'll actually know exactly what this is, how it's moving, where it's orbiting, and, of course, if this is indeed Planet 9. Right now this is just a candidate, and a very intriguing candidate, but just like with the previous candidate from a few years back, it could be a nothing burger. But despite of this, all of these searches for Planet 9 have actually been super productive in discovering so many other objects. We've actually discussed different types of objects discovered in the solar system, and even different types of dark objects discovered in the galaxy that were found by accident while looking for Planet 9. So in that sense, we should not stop looking, because astronomers keep finding so many new things nobody knew existed. But when it comes to the Planet 9 itself, the question about its existence is most likely going to remain open for at least a few more years. And today we're going to discuss some really exciting discoveries about the planet Jupiter, the massive giant that we're all familiar with, that even today is still hiding so many mysteries. But specifically, we're going to focus on one study that seems to suggest that back in the days, when the solar system was just starting, Jupiter was a lot larger in size. And there's a very interesting way how scientists were able to figure this out. And so let's discuss some of these discoveries in more detail. But first, let's take a look at some of the new imagery produced by NASA, mostly based on the observations from the James Webb and from the Hubble Space Telescope. And so extremely recently, in one of the recent observations, researchers were able to observe Jupiter's aurora. And more specifically, they were able to capture the aurora using two completely different wavelengths, the infrared from the James Webb and the ultraviolet observations from the Hubble Space Telescope. Here's actually the entire image of Jupiter in the ultraviolet produced by Hubble. And one of the reasons researchers wanted to observe the aurora is because they want to understand how they differ from other planets, such as for example planet Earth, especially since on Jupiter, unlike planet Earth, the aurora are also caused by its moon Io. And so it's not just the sun, it's also one of its moons. And the main focus was to see how quickly the aurora can change compared to the ones on our own planet. And the initial assumption was that a typical aurora might take an hour or so to completely dissipate, kind of similar to what we usually see around our own planet. But instead, the observations revealed something entirely different. Here, the variation was basically in seconds, with some aurora appearing and disappearing mere seconds in between. And mostly because a lot of the ionized hydrogen that seems to cause the aurora seems to only be able to stay in Jupiter's atmosphere for approximately half a minute. And because in this case it also affects the overall temperature of Jupiter, here it results in an extremely quick changes in temperature that seem to occur in mere seconds several times per day. But intriguingly enough, the observations between Hubble and James Webb were somewhat different. Or basically, some of the brightest lights visible in the infrared didn't actually have counterparts in the ultraviolet emissions, suggesting there's a lot of complexity we still don't understand, and suggesting that Jupiter's aurora are potentially formed in a somewhat different way from planet Earth. But in essence, this study highlights how little we know about Jupiter, and especially how little we know about its formation history and its moons. As a matter of fact, in one of the more recent studies, researchers tried to figure out how its moons could have even formed. Now, we currently know of 95 moons around Jupiter, but for the most part we have no idea exactly how they came to be. But it was always believed to be the result of some kind of a breaking apart of the initial disk that was basically formed by the Jupiter itself. And that's because, just like the Sun, Jupiter was also surrounded by a circumplanetary disk that eventually coalesced into its moons. And it's by using this disk and the assumptions about it that researchers were able to figure out so much about Jupiter's history. For example, here, by using a new simulation, researchers realized that the disk potentially contained at least two distinct regions. There was an inner ring and an outer ring. And over time, as the inner ring expanded, it basically produced a bunch of shadows in the outer ring, which would suddenly have reduced temperature in certain parts of the disk. And it was extremely likely that it was these shadows that eventually started to coalesce into most of the larger moons of Jupiter. This was recently confirmed in one of the simulations, and the study by Anton and Olivier Mussy that you can find in the description. But it was really by using the assumption about this disk that scientists were now able to work out something somewhat unusual about early Jupiter. It seems to have been much larger in size initially, and was potentially as large as 2.5 times its current radius. In other words, early Jupiter was potentially almost 3 times bigger in size and contained an enormous magnetic field, much stronger than anything today. And so let's discuss this somewhat recent study and what scientists were able to discover, but specifically discuss the somewhat brilliant technique they used for this that allowed them to calculate the initial size of this beautiful planet. Now, first of all, the first few millions of years in the formation history of the solar system are still kind of mysterious to us. And that's because we have a lot of uncertainties in regards to some of the earliest models and in regards to how planets basically form, especially planets like Jupiter. But since Jupiter is so massive, and since it's sometimes referred to as the architect of the solar system, trying to understand its formation history is obviously important in order to figure out what happened in the first 100 million years. But the question is, how do you even go back in time so much in order to figure out any of this? How can researchers possibly know how big or how small Jupiter was? Well, intriguingly, this all goes back to that disk once again. But this time, another somewhat bizarre region formed around Jupiter as a result of its very powerful magnetic field. Because here, the magnetic field would extremely likely prevent the disk from forming too close. Or basically, Jupiter would contain what's known as magnetospheric truncation, a region where the magnetic lines would just dissipate any particle, sort of leaving an empty space between the disk and the planet itself. And so technically, by figuring out how large or how small this area was, we can then figure out how fast Jupiter was spinning and eventually figure out its initial size. And turns out there is a way to do this by looking at the orbits of some of its moons. Now, the majority of its moons are pretty easy to explain, but there are a couple that seem to have somewhat strange parameters. Here's one of them, Amalthea. This is a moon that's much closer to Jupiter than Io, but it does have somewhat strange eccentricity and inclination. Now, it's actually not that dramatic, but it's dramatic enough to potentially have some kind of an additional explanation. In other words, as Amalthea orbits Jupiter, it does have an eccentricity of 0.003 and an inclination of 0.37 degrees. Barely visible, but visible. And the reason it's unusual is because it should technically all be zero, just because it's so close to Jupiter and because it's practically inside the rings. And we know that all of the particles inside the rings have circular orbits and zero inclination. And it's not just Amalthea. There are quite a few moons that seem to have something similar. For example, Adrastea and Metis also have just a little bit of inclination and a little bit of eccentricity, but it's the moon Thebe that seems to have the most. 0.018 eccentricity with an inclination of 1.08 degrees. And so these non-zero values point at some kind of an interaction with something else. And that something else has always been proposed to be Io. As a matter of fact, this study from 2004 goes in a lot of detail explaining how Io most likely changed the eccentricity and the inclination of all of these moons over time, but it can only do so by migrating toward Jupiter. In other words, the influence of the innermost satellite Io may only be explained if Io migrated from somewhere else as well. And turns out there is a way to kind of figure out where it came from or how much it traveled over time by essentially figuring out the changes in the orbits of these moons. And so by working out the orbital dynamics of some of the Jupiter's moons, researchers worked out what seems to have happened in the first 4 million years of the existence of Jupiter. And here we have two major steps. The first step happened when Jupiter was much larger and contained an extremely powerful magnetic field, and the second step was when it shrunk and became somewhat similar to how it is today, with the moons beginning their outward motion. Or just to rephrase this, at first the moons were migrating towards Jupiter, with the inner moon stopping at the edge of the disk, but afterwards there was a tidal migration, with the moons slowly being pushed away, with all of them eventually ending up in their current location. And so because Io was moving very slowly toward and then away from Jupiter, its gravity gave these smaller moons an occasional push. And these gravitational excitations, which can also be referred to as resonances, produce the inclination and the eccentricity we seem to observe. And so here it becomes possible to work out the initial location or initial position and the final position for the migration of Io. And so for example, if Io started migrating from too close to Jupiter, it would have tilted Amalthea way too much, whereas if it started farther away, it would not have tilted Thebe enough, which allowed researchers to pinpoint the exact changes in Io's orbit. And this magnetospheric truncation is basically a region where Jupiter's magnetic field completely cut off the disk. This was believed to be at a distance of about 3.6 to maybe 4.4 radii of Jupiter. And this is believed to be the location where Io settled as well. Intriguingly, these magnetic forces that also cut off the disk at the same time control the overall spin of Jupiter as well. And so basically the size of the disk edge was directly connected to Jupiter's spin rate, with the initial spin of Jupiter potentially being anywhere from about 1.1 days to maybe about 1.6 days maximum. This is actually much higher than today because current day on Jupiter is only about 9.93 hours, or about 0.414 days. With the implication being that Jupiter was much larger, it was also spinning much slower, but eventually coalesced and shrunk into a much denser object. And so by knowing exactly how fast it's spinning now, and by knowing exactly where Io used to be, scientists worked out that it was probably approximately 2 to maybe 2.5 times as large as it is today. Or basically it contracted quite dramatically over the next several billion years. And this is not really that surprising because this is kind of consistent with how we think giant planets probably form in the first 100 million years of the existence of the star system. And so it's quite likely that all of the gas giants out there essentially experienced this gravitational contraction and the reduction in size, acceleration in spin, and the decrease of the magnetic field as well, because in this case it was also discovered that the magnetic field was at least 50 times as powerful, with the peak size and the peak magnetic field being reached approximately 3.8 million years after the formation of the solar system. Now obviously it's not entirely clear what effect this would have had on the rest of the solar system yet, or even what effects this would have on the moons near Jupiter, but by figuring out these first steps here, scientists can now maybe work out why and how the solar system changed in the last 4.5 billion years. With this model also confirming that it's quite likely that all of these really large planets basically formed through the process known as the core accretion, essentially a rocky core rapidly gathering gas around itself and growing to these massive sizes in just a few 100,000 years, which is exactly what seems to have happened to Jupiter. But I guess the next question is this also something that happened to Saturn, Neptune, and Uranus? And so maybe, by using some of the moons around those objects, we can also figure out what happened to them as well, and eventually make conclusions about other exoplanets, because this is maybe something that happens everywhere. And today we're going to discuss some of the recent discoveries in regards to the interstellar medium and its potential effects on planet Earth, and specifically the medium surrounding the solar system that basically the solar system is flying through, and how all of this might have changed a few million years ago for reasons we still don't understand. But according to the recent study you can find in the description, there's actually maybe a chance that approximately 2 to 3 million years ago, the interstellar medium dramatically changed the entire solar system, which potentially led to dramatic changes on planet Earth. But first, what exactly is interstellar medium, and what's the location of the solar system in relation to everything else around us? Now, we've actually discussed this beautiful map you see right here in one of the videos you can find in the description, but this essentially shows you the Sun in relation to a lot of other stars and various clouds around us. And today, based on a lot of different studies, we're pretty certain that there are at least 2 clouds around us, with the solar system potentially leaving the local cloud and entering what's known as a G cloud, the cloud really close to us where Alpha Centauri is located as well. And these clouds are part of ISM, interstellar medium, a lot of ancient gas moving extremely fast, which when colliding sometimes creates shock waves, which result in a lot of different effects. And when enough of this gas collides, it can even lead to new star systems and new planets, with a lot of this turbulence potentially formed by various powerful stars nearby, but also by ancient supernova and the interaction with much larger molecular clouds. And while currently the Sun is traveling through local interstellar cloud, which seems to be some kind of an irregular clump of warm neutral hydrogen, at least a few light years across. And we've discussed some of the potential explanations of how this formed a while back. The video in the description talks about this more. And so basically here, this bubble expanded over millions of years, and we seem to be right in the middle of it. But even today, it's a little bit difficult to establish if any of this has any effect on the planets. Does any of this have any effect on planet Earth? And more specifically, do climatic conditions on Earth change as a result of the solar system traveling through the galaxy? So for example, as the Sun travels through various interstellar clouds and potentially enters much denser regions, does this actually do anything to the Sun or to planet Earth? Well, first, a quick side note. The answer is we still don't know. As a matter of fact, proving any of this would be extremely difficult. But one of the recent studies discusses a few correlations and tries to imply that the answer might be yes. There might be an effect after all, and specifically an effect on the heliosphere of the solar system, which then affects the planets. And so let's briefly discuss heliosphere first. Heliosphere, which we previously believed looks like this, is essentially a kind of a magnetosphere or even an atmospheric layer around the Sun. It's essentially a kind of a bubble formed by the pressure from the Sun as it travels through interstellar medium, and specifically formed by the solar wind, that actually protects the entire solar system from huge amounts of cosmic ionizing radiation, but also prevents a lot of particles from the outside from ever getting into the solar system. And interestingly, based on previous observations and studies by the Voyager probes, the same researchers also discovered that the heliosphere is more likely to be this shape, or basically some kind of a croissant shape, as opposed to an actual sphere, which of course implies extremely complex interactions between solar wind and the interstellar medium. But now the same researchers were able to analyze something else about the heliosphere and specifically discover its interaction with one of the clouds around us approximately 2 to 3 million years ago. And so here the researchers looked back in time and used computer models to try to discover what happened to the solar system approximately 2 million years ago. But they also mapped the path of an unusual formation known as the local ribbon of cold clouds. Here's an actual image of this, as visible in a hydrogen survey known as Hi4Pi. And essentially this is a large and very dense, very cold cloud made entirely out of hydrogen. It's not particularly big, but it's pretty dense. And the simulations here discovered that the solar system might have actually passed through these clouds for at least a few 100,000 years, or possibly even a million years, which essentially meant that the heliosphere very likely interacted with this dense cloud for a relatively long time. And so based on previous models of the modern heliosphere, the researchers wanted to discover what would actually happen to the heliosphere if it suddenly slammed into this thick cloud. In terms of the actual thickness, it's very similar to a typical molecular cloud where we usually find a lot of star formation, but here it's just the size is really small. This is like 100 times smaller than a typical molecular cloud. And so because the density here is up to 20,000 times larger, it would actually dramatically change the heliosphere, with the model suggesting that its total size would decrease from approximately 80 astronomical units down to about 0.2 astronomical units, suggesting that not a single planet in the solar system would now be protected or covered by anything, or essentially suggesting that all planets would now be fully exposed to the interstellar medium. And that of course includes higher radiation, but also a lot of materials such as iron-60 that usually represent various leftovers from a lot of supernova. And signs of this iron-60 from approximately 2 to 3 million years ago have actually been reported by a lot of studies out there. But previously it was assumed that it was maybe because of the nearby supernova, maybe 6 to 10 million years ago, not so far from planet Earth. But according to researchers from this study, based on the layout of nearby clouds, it would be difficult to explain this if a supernova happened relatively recently. Although here, another side note, there are studies out there that do explain these observations with supernova relatively well as well. Once again, some of the videos in the description talk about this a little bit more. But nevertheless, we now have at least one more potential explanation for all of these observations of iron-60 deposits that don't require a supernova nearby, with the explanation being that it might have been the result of a major collapse of the heliosphere for at least a few 100,000 years that very likely exposed all of the planets to interstellar medium. And if that's the case, it's not entirely clear what this actually did to planet Earth. Now in this study they do actually make implications on the Earth's climate, possibly even suggesting that the ice ages might have begun as a result of this, but all of this is of course just speculation for now, mostly because all of this is just correlation. Even today we still have no idea why the ice ages began so suddenly, approximately 3 million years ago, and why they're still going on even today. As a matter of fact, we're technically now in the interglacial period, and chances are another ice age is going to start in the next 30,000 years. But because we're pretty far away from this cloud, it will be difficult to explain why the ice ages never stopped. Nevertheless, it might have had some effects on the planet, and because of higher irradiation of the upper atmosphere, this could have affected things like the ozone layer and even the chemical reactions in the upper atmosphere that could then change the climate. But figuring out these effects, or figuring out how this affected the planet, is of course the very important part. But having this evidence that the Earth's environment might have changed 2 million years ago as a result of the location in the galaxy is actually really interesting. Around this time, this is of course where our species has gone through some dramatic changes and eventually evolved into Homo sapiens, acquiring all of the skills we have today, and though a lot of this was obviously the result of various mutations, we still don't really know if the increased radiation during this time played any role in our evolution. And so in essence, all this study shows right now is a potential change of the heliosphere that might have influenced the planet in some ways, potentially increasing various deposits such as iron-60 and plutonium-244, the isotopes of which have been discovered in various locations from around this time. But whether any of this connects to the changes in the climate and the evolution of our species is of course not a question we can answer. But what this paper can answer is that it's most likely going to happen again in the next few million years, which basically suggests that the heliosphere of the solar system is a very dynamic phenomenon and seems to change quite a lot. Although right now the scientists are focusing on even more distant past, going back in time millions of years by using various data from the Gaia telescope. And that's because by finding another cloud and possibly connecting this to even more fossil records, the researchers behind the study can actually establish this as an actual phenomenon that happens to the solar system every once in a while. And if this affects our planet, it might also be able to explain certain events, certain climatic events, that could never be explained in any other way. And so definitely a pretty interesting discovery, but it still needs to be scrutinized by a lot of other scientists to see if there's maybe additional explanations, and to most importantly see if these observations can be maybe explained by a nearby supernova after all. And in this video we're going to discuss some of the recent updates in regards to one of the biggest cometary discoveries in the last few years. The discovery of what you can kind of see right here. This is known as Comet Bernardinelli-Bernstein, sometimes also referred to as the BB comet. Discovered a few years back and confirmed in 2021, by Pedro Bernardinelli and Gary Bernstein. And as the title of this video suggests, what makes this particular comet super exciting, and I guess kind of unusual, is that this seems to be the largest comet we've ever seen coming from the mysterious Oort cloud. Initially, the size of the comet was believed to be 120 kilometers, 75 miles across, but as we're going to discuss today, it looks like the size is even larger, and in the last few years we've actually learned quite a lot about this object and about its somewhat mysterious features. And so let's discuss this comet once again, but I guess let's briefly start with the discovery, because it was just a little bit unusual. And that's because initially, when it was first seen in some of the images, researchers actually thought they were looking at some kind of a distant asteroid. It had an extremely small, point-like appearance, but right away there was something super bizarre about this object. Unlike typical asteroids, by looking at this object in other images, researchers discovered that it was not really moving that much across the night skies. It almost seemed like some kind of a star-like object and not a typical asteroid. And so because it was moving so extremely slow, this only meant one thing. It was essentially headed toward the inner solar system. It also very likely possessed a somewhat parabolic orbit, or at least an extremely eccentric orbit, or in other words, it was coming from somewhere super far away. But because initial distance calculations put this object at approximately 29 astronomical units away from planet Earth, so a little bit closer than Neptune, and because it was already visible, it only meant one thing. This was an extremely large object, and very likely something somewhat unique. With the initial discovery leading to a new race, all of the astronomers tried to find some of the previously captured images in order to discover what the motion of this object was and what the actual orbit was as well. And so by having several images going as far back as 2014, it was discovered to have this somewhat bizarre orbit. It's going to approach the Sun at approximately 11 astronomical units, so just beyond the orbit of Saturn, but it also most likely came from a distance of approximately 44,000 astronomical units away, or approximately 0.7 light years, making this a true long-period comet coming directly from the Oort cloud. But because this particular object has already started to show cometary signs, or in other words, it already started to emit a lot of stuff from the surface, even though it was pretty far away from the Sun, this implied that it potentially had a lot of pristine materials on the surface and may have only come close to the outer solar system just a few times, or maybe this was its first time. In other words, maybe something on the outskirts of the Oort cloud disturbed this object sometimes in the past, and it's now finally entering the solar system, producing all of these very unusual emissions. We'll come back to that point in a few minutes, because that's basically what the new study is all about. And so the observation of cometary activity from such an extremely distant object is practically unheard of. It's really only been seen 3 times previously, and all 3 times from extremely distant comets. The most famous one is actually Halley-Bopp. That's the comet that produced this incredible image that was captured in 1997. But unlike Halley-Bopp, unfortunately this particular comet is not going to be coming close enough to the Sun to exhibit these extremely beautiful tails. It will have some tails, but just nothing so extreme. Yet nevertheless, this is one of 3 known comets to us that started to exhibit cometary activity beyond 20 astronomical units, which can only be explained if the material on the surface is more or less pristine, potentially billions of years old, or implying that this is one of the first visits this comet ever had so close to the Sun. And while based on the observations from 2021, we know it also experienced a major outburst. Basically because the Sun was warming up this comet even at these far distances, it sort of exploded, producing a relatively large emission. Possibly as much as 100 million kilograms of dust was ejected from the surface. And, well, really what makes this particular object so extremely rare is just the fact that we technically believe a lot of these distant comets generally experience something known as fading. With every single orbit closer and closer to the Sun, they lose so much mass and so many volatile components that they eventually become completely invisible, or maybe even completely fall apart. But because this object is so massive and is already so bright, this once again highlights that this is maybe its first time here. Or in more scientific terms, this is a dynamically new comet. And based on the calculations of how long it took it to reach this point, it seems to be approximately 2.8 million years. And so if this is its first time here, it means that 2.8 million years ago, something potentially disturbed the outer solar system, or at least disturbed this comet, to suddenly change its orbit dramatically. Now obviously we have no idea what could have happened, and so this could have been some kind of a passage of a nearby star, or maybe even just the galactic tides themselves, but what's certain is that this comet that most likely orbited for billions of years on the outskirts of the solar system inside the Oort cloud is now coming closer and closer to us. And it's going to make its closest approach sometimes in 2031. But because it's going to be pretty far away from us, it's still going to be somewhat challenging to see this without a telescope. As a matter of fact, its total brightness will actually be kind of similar to Pluto, which means that you can actually see it with a telescope, but not bright enough for the naked eye observations. Nevertheless, for such a distant comet, it's already pretty bright. As a matter of fact, the early observations by NASA suggest that it already had coma and was already active back in 2018. And within just 2 years, it increased its total brightness by at least 1.5 magnitudes, basically making it approximately 4 times brighter. And while it's some of these more recent observations, and especially observations from this study by Nathan Roth and the team you see right here, that essentially revealed even more unusual observations and even more mysteries, showing us how super strange this object is. When this object was approximately 16.6 astronomical units away from the Sun, researchers were able to use ALMA, or Atacama Large Millimeter Array, to observe this object and discover what's happening around it. And so first, by using the observations in radio light, they were able to determine that it seems to be bigger than we thought. So here's roughly how it compares to Mimas and a famous Trojan known as Chiron. And because this was based on radiothermal emissions, here the observations seem to be pretty accurate, although there's still a bit of an error of plus minus 17 kilometers. But as you can see, in terms of total size, it's at least double of famous Halley-Bopp comet. It's also several times larger than the Martian moon Phobos, and nearly 50 times larger than a typical comet. And it's also 50 times larger than the asteroid Anton Petrov. Yeah, that one. The one you can learn about in one of the videos in the description. And so yeah, this is definitely large. But it's not just large, it's also for some reason extremely dark. As a matter of fact, this image kind of shows us what it potentially looks like. It seems to only reflect 4.4% of light, giving it an extremely low albedo and making it almost pitch black. It's actually been compared to coal in terms of color. And because it only reflects 4.4% of light, this potentially implies that its surface composition is extremely enriched in organic compounds, various carbons, various sulfides, but also compounds that have been bombarded by cosmic rays for billions of years. Although here, it seems to be a little bit more reflective, or a little bit brighter, in longer wavelengths, which also suggests it potentially has a very slight red colored tint. Here it's maybe kind of comparable to the redness of Pluto, but in this case much darker. But this is definitely not permanent. As it becomes activated and as it becomes a true comet, especially after its closest passage, it's extremely likely going to completely change its surface, exposing its inner structure and possibly making it just a little bit brighter. But intriguingly, because this is such a large and such a massive object, there's a very high chance that it can then recapture most of the stuff that becomes ejected for the next few years just because of its own gravity. In other words, even though it's going to lose some material as it approaches the Sun, a lot of the stuff will actually come back and fall back on the surface, sometimes before this object goes back to the Oort cloud. And so its total mass will only decrease by just a little bit. Intriguingly, this is exactly what happened to the famous comet Halley-Bopp. And once it passes the closest point, it's then going to leave this place for at least 4.5 million years. That's because its orbital parameters will change just a little bit, and it's now going to go as far away as 55,000 astronomical units away, reaching even farther regions of the Oort cloud. But going back to these new observations, here the observations also revealed extremely complex evolving jets of carbon monoxide, which kind of explains what it had on the surface and why it became a comet so far away from the Sun. So basically here it seemed to be initially covered with huge deposits of carbon monoxide. But because it also experienced a few unusual explosions, this still raises a few questions about, well, what's actually going to happen here in the next few years. As it approaches the Sun in the next 6 years from today, it will be quite interesting to find out what happens to it and how it reacts to getting hotter. But I guess more importantly, these new observations and new calculations definitively confirm that this is not just the largest, but also one of the farthest comets we've ever seen coming from the Oort cloud, making this one of the most fascinating objects, apart from those extrasolar comets like the famous Oumuamua, which a lot of astronomers are actually hoping we could maybe one day land on, collect some samples, and return to planet Earth. Because this is one of the few opportunities we have to study such a bizarre, unusual object literally coming from in the middle of nowhere in outer space. But at least for now, researchers predict that it's probably going to start vaporizing a lot more stuff on the surface, and will even eventually reveal some of its actual nucleus, possibly exposing what's under the surface and showing us what a lot of these comets might be made out of. And so in the next few years, this might help us answer some fundamental questions about the solar system, and even answer questions about where Earth might have gotten its water from. As a matter of fact, if we actually find a lot of water that seems to be similar to planet Earth, this comet might help us solve a relatively old mystery of the origin of water. But because so far this was the first detection and the first confirmation of molecular activity from its surface, it just means that this is just the beginning, and we're going to be discussing this comet more and more as it becomes more active prior to its closest approach in 2031. Approximately 70,000 years ago, our ancestors experienced something we'll never get to experience ourselves. A second star in the solar system. And that's because roughly around 70,000 years ago, an extremely dim binary stellar system, today referred to as the Schultz star, passed extremely close to the Sun at a distance of approximately 0.82 light-years, or essentially through what's known as the Oort cloud, which very likely produced quite a lot of disturbance inside the Oort cloud, but exactly what disturbance we're not going to know for quite some time, and that's because this region mostly contains extremely distant comets, and it will probably take millions of years for these comets to make it toward the center of the solar system. And so here most scientists believe that it's probably going to have some effect. But a much more interesting question here is really in regards to other changes. For example, certain orbital changes, or what's known as the orbital forcing, that might actually change the climate on the planet and potentially result in something like an extinction event, or maybe the opposite, produce effects where the climate becomes much more hospitable and much more beneficial for life. And well, hello wonderful person, this is Anton, and today we're going to discuss the study that you can kind of see behind me that essentially tackles this idea a little bit more, focusing on one of the most bizarre and most unexplained climatic changes on the planet that here researchers decided to assess using various very accurate computer models and simulations, finally providing us with certain results in regards to these star flybys, or providing us with the simple answer to the question of, can a star flyby disrupt the solar system so much that it basically causes a new extinction event on the planet and forces the climate on the planet to change dramatically. And that's because even though the human lifespan is relatively short for most of this to make much sense, when you look at a much longer scale, in millions or especially billions of years, since we get so many different stars flying next to us, here the disruptive effects are quite possible. And so could such a passing star sometimes in the past disrupted Earth's orbit so much that it suddenly caused a shift in climate that might have resulted in something extreme. And in this case, scientists wanted to focus on one of the most bizarre and still unexplained events that happened 56 million years ago. This is known as PETM, Paleocene-Eocene Thermal Maximum, that we've actually discussed several times before, and that in some sense you can see as this unusual green blip or unusual surge that happened approximately 10 million years after the dinosaurs went extinct. And well, even today, despite all of the studies and all of the research, nobody actually has any idea why this happened, even though there are obviously quite a lot of potential explanations and different propositions. With one of these potential propositions being some kind of a star flyby, kind of similar to the Schultz star that happened 70,000 years ago. And while some of the studies previously did actually suggest that 70,000 years ago there might have been a dramatic climate shift from a relatively wet period to a slightly drier, colder one, which potentially led to a dramatic shift in what humans were doing. Specifically, it might have influenced early human migration, because the expansion of grasslands and deserts in certain regions provided the means and possibly reasons for humans to leave Africa, which then led to the spread of humans across the planet and the extinction, or I guess, absorption of Neanderthals. That's because most of us usually contain at least some of the Neanderthal genes. And obviously this climate change could have been the result of something else, mostly because we do have a lot of different climate shifts, mostly because of the orbital changes known as the Milankovitch cycles. Here, some scientists suggested that maybe it was the short star after all. Maybe this is actually what gave humans the reason to leave Africa and to eventually become the dominant species. And just as a fun fact, the next major flyby is going to be a star known as Gliese 710. You can learn more about this in one of the videos in the description, but this flyby is probably going to happen approximately 1.3 million years in the future, with the average distance of approximately 11,000 astronomical units, or even closer than the Schultz star. And so that's sort of the main question this new study was trying to answer. Could some kind of a passing star disrupt the Earth's orbit enough to dramatically shift the climate? And while some of the previous studies based on slightly simpler models discovered that there was possibly some kind of a change that could maybe shift the climate, but this new study by Richard Zeeb and David Hernandez decided to just go all in. They created the most complex model involving the most complex orbital dynamics and most importantly our moon in order to calculate how likely is Earth orbit to change if there was, for example, another Schultz star passing nearby. Now, interestingly, not so long ago, there was actually a study suggesting that roughly around every 50 million years, some of the climatic changes might be caused by these passing stars, with at least one study implying that PETM was indeed the result of a star flyby. But this new simulation and new model using the state-of-the-art solar system model, most importantly including the lunar effects, seems to discover practically the opposite. And here this involved 400 separate simulations and approximately 2,000 different stellar flybys in order to assess potential orbital evolution and potential gravitational perturbations as a result of a giant object suddenly entering the solar system, or technically entering the outer solar system and specifically the Oort cloud. Here we're talking about a distance of approximately half a light year. Now once again, there's going to be at least some effects, such as for example cometary perturbations, but here the main question was orbital evolution of planet Earth. And it looks like, according to this study, there seems to be no influence of passing stars. After many simulations, scientists discovered that there seems to be no influence on the climate of the planet, even when stars came relatively close. And here there is only one reason. The reason is our moon. One of the main reasons other models had different results is because there they just included Earth without our super important partner. But turns out that by including the moon, which is actually quite difficult to assess even using modern computers, does result in orbital stability, mostly because of what's known as J2. This is the so-called moon and sun quadruple moment, which stabilizes the orbit of planet Earth. And so here the overall conclusion is that unless the star comes super close, which is actually extremely unlikely, overall these relatively far flybys seem to have no effect on the planet, at least in terms of orbital changes. There might still be some effects because of the cometary changes, so basically a lot of particles and comets coming toward the inner solar system, but here we just don't have enough evidence, and all of this is just based on the assumptions. To date, there is still no evidence suggesting that flybys increase cometary activity, even though it's kind of assumed that this might happen. And so when it comes to PETM, that resulted in this very dramatic shift in temperature, increasing it by about 8 degrees Celsius, 14 Fahrenheit, and that actually resulted in several extinction events as well. Here, right now, the best explanation is still a dramatic influx of carbon into the atmosphere. And if you'd like to learn more about PETM and what we believe might have happened, check out the previous video in the description. Which also means that future flyby of Gliese 710 is unlikely to have any major effects either, even though it's going to come much closer to the Sun and will be much easier visible. And so whoever is going to be on the planet, possibly studying the night skies and possibly observing the night skies, is going to be quite pleasantly surprised. Just like our ancient ancestors, they're going to see a new beautiful star, most likely visible at all times. But even though there is no change in terms of climate and orbital changes, now a much more important question would be to basically assess how this affects cometary activity. Is there a higher increase in, for example, collisions or maybe the increased amount of dust in the inner solar system that could somehow change the climate by, for example, blocking the sunlight? Well, that's not something we know right now, and that's not something we're going to be able to discover anytime soon, because when it comes to timelines here, comets usually don't survive long enough to connect them to various star passages. And even though some comets can survive for thousands or even maybe millions of years, once they do become active, they typically only survive for weeks or maybe months before falling apart and potentially becoming something similar to a typical asteroid. And so trying to assess the cometary effect right now is not something we can do yet, mostly because there's just no way to assess the evidence and no way to connect these cometary activities with previous flybys. But we are actually going to be discussing a bunch of cometary discoveries in some of the future videos, so do subscribe if you'd like to find out more. As a matter of fact, we're going to be discussing the largest comet ever discovered that's now revealed something new and unusual, and something that nobody expected. But on that note, the overall conclusion from this study is that, well, flybys do not seem to cause climatic changes, at least for planet Earth. When it comes to other planets like Mars and Venus, the story might be different because they don't have a massive enough moon to maintain the orbital parameters, but Earth seems to be pretty safe. But this actually brings up a good point. We know that Mars, for some reason, flipped its axis quite dramatically for reasons that are still not understood. And for all we know, maybe these stellar flybys do affect other planets. And though this is not something that can be assessed yet, we'll definitely come back and discuss this more if someone finds a way to explain this. Subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads, and can send me DMs and stuff. Maybe support this channel by joining the channel membership where you can get early access to a lot of different videos, or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.